to you about using AWS Control Tower and Okta to scale your AWS cloud safely and efficiently. Let me see if we can advance here. All right. Um, as with every organization, I'm sure your IT is constantly under pressure to simplify their end-to-end IT lifecycle management to support business agility while still able to hold strong grip on the environment. Your business usually comes knocking on your IT door, requesting things to get done almost immediately to address your client's needs. And you still have these standard security procedures to follow. Now, with that kind of pressure, IT is often forced to choose between business agility and governance controls to maintain security. It used to be one way or the other. How about what if you can have both in your AWS environment? Does it sound too good to be true? Are you familiar with AWS management and governance services? When you deploy management and governance services on AWS, you can relieve from that pressure. You, as IT organization, don't have to constantly struggle between doing things fast and doing things right to keep everything secure and keep the business running smoothly. We have 16 management tools in our console. Some of them you might be very familiar with, and Frank talked about them a little bit earlier: CloudWatch, CloudTrail, CloudFormation, and AWS Config. Today, I'm gonna focus on AWS Control Tower. Now, before I jump into it, I'd like to mention that there's also a full complement of third-party solutions on AWS Marketplace you can use to extend and integrate with these native services. From working with a lot of customers, like thousands of them, we've learned that there are three aspects to achieve both business agility and governance control so that you can have optimal security. The three aspects are enable, provision, and operate. AWS Control Tower helps you achieve all these aspects for your multi-account AWS environment. AWS Control Tower is a managed service that provides the easiest way to set up and govern a new secure multi-account AWS environment based on best practices established through AWS's experience working with, as I say, thousands of enterprises as they move to the cloud and we help them move to the cloud. You could initiate the AWS Control Tower deployment from the AWS Management Console with just a few clicks. And there's a form for you to fill in, and there's only a couple fields for you to fill in that form. It takes about 60 to 90 minutes to launch an AWS Control Tower on a new AWS account. And this got to be a primary payer account. Now, before AWS Control Tower, it used to take about 6 to 9 months for our professional services team to help you or to help the customer establish their landing zones, security baselines, and third-party integrations. It's a big difference, isn't it? So I recommend customers like you deploying a new environment to start with AWS Control Tower. You can have, even when you have existing environment with AWS, I also recommend that you leverage the Power Control Tower to extend governance into your legacy accounts and implement Control Tower guardrails going forward when you create new accounts. Control Tower takes care of all the best practices for you, from fundamental accounts to blueprint and guardrails for security and monitoring. And Control Tower also comes with Account Factory. It used to take a village to spin up a new account with the right AWS service control policy, AWS config rules, VPC, security groups, standard software solutions, WAF, firewalls. Now, AWS Account Factory makes account creation and provisioning very easy for you. It takes a few clicks and voila, your new account is created and also compliant with your security policy. So when you deploy Control Tower, Control Tower enables you to set up a AWS landing zone. And I will talk about landing zone in a little bit. Then it creates a centralized identity and access framework based on AWS SSO for you. The next step is for you to establish or Control Tower to establish guardrails for security, compliance, and operations. And we will dive a little bit deeper into guardrails later on. Once you have the security baseline set up, you can use Control Tower to automate compliant account provisioning. Now, why I say a compliant account provisioning? Your new account, once created, will have the same cookie cutter baseline, including third-party software solutions required for your organization, your transit VPC gateway, your security groups, anything that you need to customize to get that account ready for production for your environment. And then after that, you can manage your environment continuously over time as you grow your footprints on AWS. AWS Landing Zone is a solution that helps customers like you quickly set up a new AWS environment for multiple accounts. The AWS Landing Zone solution can save you time by automating the setup of your environment in line with AWS best practices recommendation. With the AWS Landing Zone, you receive a baseline environment that gets you started with a multi-account architecture, identity and access management, governance, data security, network design, and lock-in. And there's a centralized lock-in, not just any lock-in. This solution was built to help you set up net new AWS environments, but you can also use it to scale to support production implementations for large-scale migrations as well. So let's check out this recommended approach for your multi-account environment. If you see under AWS organizations, you should set up several organization units or OUs. At the bare minimum, you should have core OU. The core OU contains all the necessary security and infrastructure accounts to run your shop. Log archive is for central login. Everything API related, every API calls or even VPC flow logs, you can forward into that log archive and Control Tower can automate everything like that for you. Security or audit accounts. So your security team can go in and do their magic, do break glass procedures or do auditing. Optionally, you can also have network account for connectivity and share services account to run your utilities and tools. Then you should slice up more OUs for team accounts, dev, QA, CI/CD, prod, stage, human resources, finance, legal, anything you want, however you want to address your business requirements. Now, last but not least, I highly recommend that you have a sandbox environment, a sandbox OU, or sandbox account for your engineers to play with. So you can test out new tools, test out new software, or you can use it to collaborate with your partners because usually these sandbox accounts or developer accounts, they are isolated from the rest of the environment, the rest of the network. Control Tower come with guardrails. Guardrails are the security centerpiece of AWS Control Tower. Now think of guardrails as the rails or the ladders along the two sides of the lane at your bowling alley. You can throw and spin the bowling ball however you want to on the lane, and it will not fall off into the gutter. Guarantee your attempt. And no, it's not cheating. There are two types of guardrails, preventive and detective. AWS Control Tower comes with about 40 plus guardrails out of the box. You just have to pick which ones you want to enable for which organizational unit. These guardrails then cascade down to individual accounts. And later on with future release, we will have customized guardrails as well. You can bring your own guardrails. You can build your own guardrails for your AWS Control Tower environment. The guardrails are very self-explanatory. They are in layman terms, so you don't have to spend too much time digging deep to understand what they do. For example, there's a guardrail called disallow actions as root user. You can secure your AWS accounts by disallowing account access with root user credentials, which are credentials of the account owner, and allow unrestricted access to own resources in the account. And you don't want to do that. Why? Because you should instead create AWS Identity and Access Management or IAM users for everyday interaction with that or with your AWS account. On top of that, out of the box, there will be some mandatory guardrails to ensure integrity and security of your environments. For example, no one can delete CloudTrail events, or every time you have an S3 bucket, it should be default to private and encrypted. The users in your organization, they always can access your AWS accounts via either management console, COI, or API. When you are dealing with multiple accounts, managing access to these accounts could get challenging very quickly, as you already know that. You should configure or utilize AWS single sign-on to simplify allowing access to multiple accounts without having the burdens on your IT operations. AWS Control Tower configures AWS single sign-on or AWS SSO automatically, making it easy for you to manage SSO access to multiple AWS accounts and cloud applications centrally. AWS SSO is a full-featured directory service for your AWS environment. You can just provision users and then map them to specific roles, groups, or permission set for target accounts. AWS SSO provides you a login URL. You share that URL with your users. Once they are authenticated or logged in, it presents them with a list of accounts and roles that they are allowed to assume on the accounts using SDS. They click on that and voila, they are logged into the account they want in the role they are allowed to assume. So why do you want to use Okta and AWS Control Tower? You can use AWS single sign-on or AWS SSO to authenticate identities from external identity providers to the SAML 2.0 standard. This enables your users to sign on into the AWS SSO user portal, as I talked about earlier, with their corporate credentials. They can then navigate to their assigned accounts, roles, and applications hosted in the external identity providers like Okta. Okta is cloud-based identity and access management, and they have integration with that enable IT teams to centrally manage and automatically provision access permissions across all users, roles, and AWS accounts. AWS Control Tower fully supports Okta as an identity provider. Now, besides being an identity source, Okta also can interact and support automated provisioning. So every time you create a new user or group, they will get synced up with AWS SSO automatically. You don't have to manually sync it. So it's making it easy for you to do access management. You can leverage Okta integration with AWS SSO to enable single sign-on authentication into different AWS accounts that I talked about earlier. And these accounts are managed under AWS Control Tower. Or you can also leverage Okta advanced authentication capabilities with AWS to seamlessly manage authentication, authorization, and role provisioning as you create new accounts. Through our seamless integration, Okta assigns and maps AWS roles to end users to manage their access to different AWS accounts managed by AWS Control Tower. It doesn't matter if you have a 10 or 1,000 accounts. The integration is completely cloud-based. So there's no software for you to install or any kind of software for you to deploy. The integration leverages Okta advanced IAM integrations with AWS, such as our multi-role, multi-account connector for seamless provisioning. Additionally, Okta can also allow IT administrators to federate identities against Microsoft Active Directory or Microsoft Azure. Combine Okta capabilities to manage and roles simplify the creation and governance of multi-accounts, and then help you eliminate the need to migrate IAM logic into IAM on AWS. Once the integration is set up, it's very simple to assign users to roles in Okta, and then use those Okta roles to grant access to various combinations of AWS roles and accounts. So the integration is pretty straightforward. Although there's some switching back and forth between AWS console and Okta console. So you configure you log into AWS SSO, you configure an identity IDP or identity provider in AWS SSO as your identity source, as an external identity source. You collect the AWS SSO ACS URL, which is an endpoint to redirect authentication response. You download the SAML metadata from AWS SSO as an XML format, and then you switch over to Okta console. You usually have to create a new application on Okta. You can call it whatever you want, AWS integration, and then you can download the federation metadata from Okta. And then you import the AWS SSO metadata, the XML file, into the application you just have created on Okta. Then you switch back to AWS SSO, and then you can import that Okta IDP metadata back into AWS SSO. Then after that, you can configure SSO users, groups, and permission sets according to your requirements. So customers always ask about the best practices every time they provision, implement, or operate on a platform, especially something on IAM and access management on AWS. So let's take a look at some of the recommended best practices for AWS Control Tower and Okta integration. And it also covers your IAM strategy as well. So the first one is consider a phased approach. You should start with a specific team, a small team, for example, developers or engineers, functional areas like stage and environment, QA, or testing, or AWS services, or certain AWS services. So by limiting your scope, you can avoid dissecting thousands of AWS roles and instead focus on evaluating access needs for that specific team or specific functional area. You then should leverage our joint solution to apply pre-mapped identity policies based on best practices. You should set up boundaries in your AWS environment. AWS Control Tower features such as guardrails make it even easier to spin up more AWS accounts as opposed to fine-tuning user permissions within a primary account. As you begin to expand out your environment with AWS Control Tower, Okta integration lets you automatically provision accounts with complementary IAM limitation. You can then modify these restrictions and adjust as needed as your needs evolve. You should make sure at least privilege principle is always applied. Every organization is unique in their security approach. First, you should evaluate the access needs and area security strategy for your organization. Leveraging Okta identity templates ensure that you are following best practices such as least privileged access. And then you should leverage AWS IAM roles to apply more granular security permissions as desired. For example, you should create role-based access control for AWS. Own users in the engineering role could be granted admin access on various developer accounts, while those users in the legal role would be granted access to the service user access in the legal accounts. You should always review your authentication strategy. For the selected group of AWS users, determine the appropriate authentication pathways and security protocols. How and what they will be accessing within AWS: console, command line, database, or storage, what will be your authentication sources? Is it Okta as a standalone or federated into Microsoft Active Directory or Azure? When would you like to apply additional layers of access security for specific teams or resources? For example, you can use Okta to enforce multi-factor authentication or MFA for own developers or high-risk logins, or restrict login access to the VPN only. Once you determine the appropriate strategy, set up Okta multi-role and multi-account connectors to securely authenticate those users into those services via seamless login console. Don't set and forget. Instead, never stop iterating. The business environment changes continuously. Compliance and risk requirements continue to evolve, and new insight requires new measures to better monitor your environment. The combination of AWS Cloud and Okta, which is a cloud-native solution, makes your life a lot easier to make changes and replicate those changes throughout your environment at the speed of your business. So how can you get started? The new Okta for AWS Control Tower integration provides AWS customers like you with enterprise automation and scalability as you build out your AWS environment based on best practices gained from working with thousands of enterprise organizations moving to the cloud. And every day we talk to these organizations to learn more and more about the business, their struggles, and what they would like to have in the next release to have more features in our integration. If you already have deployed Control Tower, awesome. This integration is available today. You can try it yourself by creating an Okta developer account for free and following instruction on our joint setup guide. You can search for it on AWS site. Now, if you're considering Control Tower because you are having multiple account problems or challenges, please contact your AWS solutions architect. We are always excited to help you tackle challenges, especially complex like this. We love it. We can provide many resources for you to get started, from working with you from immersion day to workshop, to help you feel comfortable in your new AWS Control Tower environment. Thank you.
All right. Hey, Nam, that was a lot of great information. You know, we have time for some questions. We've got a number of questions that have come in. So first one here, does Control Tower automatically include AWS well-architected security pillar guidelines?
It doesn't, but it's actually based on the AWS well-architected guideline. So we actually work hand in hand with that team to make sure that everything they recommended will be included in Control Tower.
Makes sense. Now, in terms of Control Tower availability, where is it available? Is it available in GovCloud specifically?
It's actually available in the public cloud or commercial cloud. It's not available in GovCloud yet. Yeah, and it's available in many regions as well. From the U.S. to Europe to Asia Pacific.
Makes sense. Now, from you're talking about multi-account here, but from a multi-cloud approach, any suggestions, any recommendations on how IAM could be designed and engineered?
This is a bigger questions on the multiple cloud strategy. AWS Control Tower is designed for AWS Cloud specifically, and you can extend it to certain on-premises aspect as outpost. But for multi-cloud strategy, this is a little bit out of scope for Control Tower.
Got it. Yep, makes sense. Now, you mentioned Okta, and certainly Okta is very popular. There are also other popular identity providers as well. What about using some of those other ones like Shibboleth or something else?
Oh yeah, obviously. We beside Okta, Control Tower also support one login, ping identity, and also Microsoft Azure or Microsoft Active Directory directly. You don't have to go to Okta or Ping ID or OneLogin.
Yeah.
So we
Now,
work with a variety of identity providers.
great. Now, related to that, can you describe a little bit? Use Okta again as an example. We've got one comment in your Slack channel here in terms of, hey, if you're, do you really need Okta? What if you just want to use AWS SSO directly?
AWS SSO is a full feature identity providers, identity source. So if you don't want to use Okta, you definitely can use AWS SSO for your authentication or IAM, identity and access management needs for your AWS Control Tower environment.
All right, and hey, just a reminder for everybody, Nam will be, here, Nam checking out some of the comments in the Slack channel. But there is another one here in terms of what about integrating with on-prem Active Directory? How would you set that up with Control Tower, or how would you think about that in terms of your architecture?
We do have integration guide with on-prem Microsoft Active Directory, but you need another you need another federation point or endpoint to help AWS SSO connect to that on-prem Active Directory. And it's a little bit more involved than these cloud native solutions, but it's possible and it's been done many times. So if you are interested in finding more about that, we can definitely set up some time with your account team or your solutions architect to connect with us to dive deeper into this.
Yeah, and having read a lot of AWS documentation, I know that AWS has some really good technical information online explaining all of these things and how to set all of this up. So that's another very good resource. Another comment here is it sounds like we've got a situation where someone is working with multiple different clients. For Control Tower in particular, in terms of using it with different client accounts, should each client have their own Control Tower? If you have many clients with their own AWS accounts, what's your suggestion there?
It actually depends on how you manage your client's environment. Are you just going there and help them spin up their environment, or you're going to be a managed service provider? Now, we work with a lot of managed service provider, and each service provider works differently. You can set up each client their own OUs, and then within the OUs, you can slice up their accounts in for product engineering, HR, however you want to do it, or you can give them several OUs, and then you give other clients several OUs depending on their requirements. And as a service provider, if you want to manage your client environment, that's how you should do it. Or if you don't want to manage that, you can just spin up different. You can create multiple Control Tower environment as long as you can create multiple primary payer accounts. And a lot of customers, most of the organization have multiple primary payer accounts, and they can just spin up multiple Control Tower environment within that organization as well.
All right. And looks like this might be the last question. Any best practice suggestions on using AD Connector or Trust for Active Directory for federated users?
Can you repeat the questions, please?
What is the best practice to use AD Connector or Trust for Microsoft Active Directory for federated users?
Well, usually we trying to recommend customers to go to another provider because the other provider they're more specialized in connecting with Microsoft Active Directory. We do that too, but there's some synchronization that you have to tweak to make it work seamlessly with AWS SSO versus going through Okta or OneLogin and then going to Active Directory. that seems to work a lot smoother than going directly into Active Directory and tweak those configurations.
Mm-hmm.
It's like having a liaison between the two providers. It seems to grease the wheels a little bit better.
Mm-hmm. Mm-hmm.
Yeah.
Makes sense. Well, Nam, judging by the number of questions here, this is definitely a hot topic. People are interested in trying to figure out how to design this, how to build it, how to engineer this. So yeah, a lot of great information. Appreciate it, Nam. And everybody, Nam will be, I think, available here for a little bit in the Slack channel. So you might want to check that out, Nam. Thanks, everybody. Let's give him a virtual round of applause.
Thank you.
Yeah, thank you. All right. I'm going to go ahead now and switch gears and tee it up for the next speaker here. Our next speaker is Ryan Nicholson, and Ryan is the author of the SANS SEC 488 Cloud Security Essentials class, as well as an instructor for the SEC 530 Defensible Security Architecture and Engineering class. Now, with that, I'm going to turn it over here now to Ryan to talk about moving operations to the cloud.
There we go. Okay, I got my microphone now. So good morning, US. Good afternoon, evening, early morning, wherever else you are coming from when you're tuning into this presentation here. So my talk is titled Moving Operations to the Cloud. And the reason I put this slide deck together in the first place some months ago was I wish I had this kind of talk when I was working in my previous position, to where we were instructed, we're moving to the cloud, right? We have any new application that we're going to be spinning up, we're going to be moving out of our on-premise data center into a particular cloud environment, or cloud environments in our situation. We were, multi-cloud rather early on. So this talk steps through some of the, and it's for the type of folks that are facing similar situations, to where I've got this on-premise thing, this application, for example, that I'm running on-premise. What are the gotchas? What are the things I need to be looking out for? And from both an operations perspective, as well as a security team's perspective, of course, me being a diehard defender, that's always in the back of my mind when I use this new technology. What are those gotchas? Where am I losing control? Or even better yet, where can these new cloud services help me do my job much more efficiently here? So here's the agenda that we're looking at for this particular talk. First, I'm going to really briefly, because I only have 35 minutes or so buckle up. There's a number of slides here. First, briefly introduce myself and my background. I then talk through a couple different topics here, like, first of all, moving to the cloud. Why are we moving to the cloud? And what does that look like? Using a case study, which is our next section that I'll talk through. We have a certain case study which may may hit home for a lot of you, moving your initial first web application, in this case, over to a cloud environment, what that would look like. And then, of course, being an AWS sponsored event here, AWS services that can help you along the way. And again, I've used several of these services way back when I was trying to move things into a cloud environment. So plenty to talk about here. Learn from my experience at this point. Then any concluding thoughts that I have just in general as it relates to cloud technology and moving your operations out to the cloud. So really briefly, as I said, just a little bit about me. As of May of this year, middle of COVID, I became a SANS certified instructor, which I know it's the crowning achievement of my career thus far. It's a very rigorous process. I'm very proud of myself, and I'm very proud of SANS for putting their faith in me and coining me a SANS certified instructor. Also co-author, sole author of SEC 488, with the new version coming out at the Cyber Defense Initiative just next week. So we have a brand new version of that course coming out. Very excited about that. So if I'm going to, of course, hint at any courses, a lot of this material, as you're going to see coming up, is featured in SEC 488 as well, and a host of other topics as we talk through cloud security essentials. Day job, I work for SANS as well. As you can see, I'm kind of all in with SANS at this point. It's my day job. I'm an instructor. I'm an author. It's a little bit of background. Again, just love getting certifications. I can't seem to stop. I've got a little bit of a problem, I would say. Also a recovering, and for some of those I've noticed were in the, based on the questions I saw with the last talk, some of you are in GovCloud. Well, you may have, I may have some things to say coming up about GovCloud. That's where my first cloud experience actually stemmed from. Just a little trivial thing about me, I'm also a guitarist, so just throwing that out there. Any fellow guitarists in the room, good stuff. All right, so into the meat of the talk here. Can't spend too much time talking about myself. So let's first dabble in what this talk is all about, and that is we are moving to the cloud. Many of our organizations are already there. Many are dabbling in it. So what do we need to know about it, and why are we moving there in the first place? A lot of the cloud vendors out there, AWS, Azure, Google, you name it, right? They're going to be touting, come to our lovely our lovely infrastructure here. We provide you scalability, failover, very high uptimes, rapid provisioning, and for the CFOs in the room, or for the company, I should say, pay for only what you need. So a lot of this does ring very, very true here, because doing a lot of these things that you're seeing on the slide on premise was predominantly very, very expensive to pull off. So now cloud natively supports a lot of these things for you. If I want to have redundant systems, a lot of times it's toggle the correct switch and it magically happens behind the scenes for you. Now there is a lot going on, of course, that the cloud vendor is doing for you, but it's a much easier barrier to entry when you want to start doing these things that you're seeing on the slide here. However, though, a lot of the initial moves into the cloud environments are typically, it could be regulation, like in my case, where it was, you are moving to the cloud, no ifs, ands, or buts. Just do it, make it happen. And those initial moves to the cloud often entail taking what you have in an on-premise environment and just duplicating that out in the cloud. And then, as you learn more about that cloud vendor environment, start using some of those cloud native services to help you along the way. So in the example here, we might have 3 servers on premise that we're using now. We'll just recreate that in the cloud. Again, that's a very common initial move for those that aren't as experienced in the cloud world, but we'll talk through several services that could be leveraged to ease that shift into the cloud, not just from an operations perspective, but also from the security team's perspective, of course. Okay, so the first step often, at least from the operations perspective, like I said, it's typically going to be where I'm going to take, if I have 2 web servers and a database server, I'll typically migrate that over if I don't know what these other cloud services at my disposal are. But you may, of course, want to do the research if you're an operations person. How can I make my job much easier here? So if I'm, say, moving a web server over into this environment, what do I have at my disposal? Do I just want to spin up a virtual machine and manage the operating system, manage the application code itself? Do I want to do all that, or do I want to look at some kind of cloud service to do this for me? And there are several options out there, again, depending on the vendor, and most vendors do support these as well. First being, of course, well, I could go with this new industry buzzword now, serverless. The first example that I have is cloud storage. Cloud storage is often, it often makes the news, when there's a breach of a cloud environment. It's often, S3 buckets, right? We all have heard the negative connotation behind S3 buckets, and you'll see metrics out there like 7% of S3 buckets are public. Well, some of those, yes, that's by accident, but some of these are going to be on purpose as well when you start spinning up static websites now using cloud storage. Your major vendors are giving you this ability to do this now. So, and what I mean by a static web server, that if you're just serving simple files like HTML files, CSS files, JavaScript files, things that aren't going to be running on a web server, you're just serving files, you can easily do that now with cloud storage. So if you put yourselves in the shoes of those operators, or if you are on the operations team listening to this talk, that's a huge win for you all. Because again, no operating system to manage, no application to manage. I'm literally just pushing my files out to an S3 bucket and luring my users there instead of my web server. For any dynamic web code now, again, we can think outside the box a little bit and move towards functions, which are, like in AWS's case, Lambda, right? You can have a Lambda function. Instead of your web server running that dynamic code on the server side, you can now have a Lambda function do that for you now. So really cool stuff here when we're talking about moving outside of just running something in an instance. Databases, of course, managed databases are a huge win. My pain points from way back in the day when I was a systems administrator, my least favorite thing, was actually 2 of them, Active Directory and database servers. So the fact that managed database services are out there now with your various cloud vendors is a huge win for that operations team as well, I'm assuming, right? Because again, unless you're a special kind of person that loves managing operating systems and database software, it'd be a breath of fresh air moving to this managed database environment. in this case. But we're going to start talking about a little bit more from the operations perspective, but then pivot over to security really quickly here. So the last bit from the operations side that I really want to focus in on is network appliances. Data centers are just loaded with network appliances from both a security perspective and just moving packets throughout the network. But again, now we're moving out to a cloud vendor, a cloud hosted environment that manages a lot of this underlying networking for us. We have a little bit of influence, of course. We can set up route tables, we can set up security groups, which is the layer 3 and 4 filtering and so on. But a lot of these things that we typically manage and these very expensive products that we manage on premise typically will have some kind of cloud service variant out there, which again can save us money, can save us time in operations if used appropriately. That's why I have the little star there with the no more expensive network appliances, because these services can get a bit out of hand if you're not careful. If you're just using the largest instance available all the time, no matter what, whether you need it or not, that can lead to some costs that may actually dwarf what you were paying on premise. So in a perfect world with a good steward of your cloud services, you should be able to save some money in this case as well. But this chart breaks down some of those commonly used on-premise appliances that you may have or services that you may have, and then the cloud services as they relate in AWS in this case. So you can see some of the common offenders here, like network load balancers. Of course, there's going to be a service for that because of the elasticity and availability that the cloud vendors provide to you. They, of course, would have to give you the option to load balance this traffic and use this appropriately. Web application firewalls, AWS Shield is available. Layer 3 and 4 filtering, which I'll talk a little bit more. I'll hold off on that, but we can see some examples here: security groups, network ACLs. And a late breaking one, I actually wrote a blog post about this just a week or so ago, the AWS network firewall. Now we're starting to see some things that talks above and beyond layer 4, but I'll have more to talk about when it comes to some of these services coming up here very shortly. All right, there we go. So I'm going to first present like a case study, which may be very common to what, again, you're moving out to your new cloud environments. And the little example that I'm going to show here is just a very, very simplistic network diagram. I don't even want to call this a network diagram, just a really high level diagram showing the before and the after picture, going from an on-premise environment for this particular application out into a cloud environment. And here we see, again, a typical network layout where we'll have a demilitarized zone or a DMZ where web services, public-facing web services often sit, or they better sit, right? You don't want this in your internal network, of course. If they're compromised, they're already in the belly of the beast here. But this is the typical layout you'll see of these web servers in the DMZ, database backend servers in some kind of other screened subnet somewhere deeper within the organization. And those are the two components that we're going to lift and shift, if you will, and take those out of this environment and put into the cloud environment. But notice some of the security products that we have in place here. We likely have a next generation firewall. If you're playing buzzword bingo, by the way, you're going to have blackout here very shortly. But we have a next gen firewall doing a lot of that application layer inspection, layer 3 and 4 inspection as well, ensuring it's proper web traffic destined for our web servers and so on, right? We also see that we have some intrusion detection systems here as well, looking for known malice, if you will, based upon signatures that it had seen in the past. So, and then of course, within the internal LAN, we're going to have possibly even more firewalls, maybe a database firewall there as well, and other host-based protections and network-based protections may be included in the internal LAN environment. But when we shift gears now and move out to AWS in this case, notice that the web and database servers are now sitting in some way, shape, or form out in the AWS infrastructure now, out in that cloud account that we're currently managing. So if you look where our lovely attacker in the hoodie here, you can always pick out attackers, by the way, when they're wearing hoodies, but they're not going through our internal LAN at all anymore, unless we get some really creative network engineers to try to force them through our security appliances that we're using on premise. Most organizations are not doing that. They're directly going to be accessing these services. So we're losing a lot of the capabilities that we had before, at least right now. The next gen firewall really isn't doing anything. You could argue if we have internal users that are accessing our web server and attacking it, then yeah, it would see that. Same goes for the IDS that we have on premise. It's not going to see this traffic. So as of right now, if we just spun up an instance to serve our web content and we have this managed database service, we're reliant solely upon what the cloud provider gives us here, unless we start to add on some more services and some more functionality, which we will be getting to very quickly here. So first though, we got to talk about what certain threats may be coming our way, targeting our cloud-based now, web server and database server. Now, I said cloud-based, but it really doesn't matter at this point because these same threats tend to exist whether you're in the cloud or not in the cloud. Yes, there's going to be some nuances to cloud. There's going to be a larger threat landscape out there, but for all intents and purposes for our little discussion here, we'll focus on some of the more common web-based attacks, like an attacker tried to discover known vulnerable web pages. Anytime you see a brand new WordPress vulnerability out there, for example, and if you're hosting something, hosting some web content, you pay attention to our logs, I guarantee you within a matter of minutes, you're going to see some folks looking for that vulnerability, looking for that page that introduced that vulnerability or that plugin, for example. So they're going to be looking for those sorts of things. Any pages with authentication, of course, they're going to be trying to look for. And if they discover those, they may try to brute force or use a word list attack to try to break into that, that secret area of your web server or that sensitive area of your web server. And of course, any other OWASP top 10, OWASP being the Open Web Application Security Project, any of their top 10 vulnerabilities, SQL injection, command injection, cross-site scripting, you name it, right? Those are the types of threats that may be coming your way if you're hosting, whether you're in the cloud or on-premise. So now that we're putting these services outside the purview of our on-premise security devices, what do we do now? So we're going to talk through some of these new challenges because we're going to be losing some things from on-premise as well, not just the security appliances, but like our log data. Where's that relevant log data that we can see an attack coming or seeing an attack in progress and put a stop to it? So where are these logs now? How can my analysts now run down an attack or my forensics team figure out what the heck happened after a compromise? So there's a lot of challenges that we have to address, which again, we will, but I just want to lay the groundwork here. Our network security monitoring tools, again, we have to think of some solution around this because we don't have that IDS anymore on premise to support this cloud workload. What happens with our SIEM? How do we integrate, once we get this data now, how do we get this data to our SIEM? And finally, which is great stuff coming in a newer course with SANS, SEC 541, there's going to be just some discussion on automating responses to an attack. So how can we do that? What are some techniques we can put into play to automate, to try to take the human out of the response, to get much more real-time automation to these attacks, put the stop to the attack, stop the attacker in their tracks to the best of our ability by using some cloud technology to our advantage here. So the first bit, though, is there's always an additional threat when it comes to hosting things in anywhere, right? Because we were doing this on premise. When we're supporting our customers or our clients with web technology, for example, we want that web technology to be available to them. We could be losing some business. So with scalability and redundancy in the cloud environment space, we have to account for that there as well. So that's something we, of course, need to research and make sure is available because stuff happens, right? A web server could potentially go offline. And if we don't have scalability and redundancy considered in that case, where you can fail over to, say, another region or another availability zone in the event that, yes, even the cloud vendors do have outages, we need to be prepared for that as well when we start deploying this thing. So it's not just lifting that one web server and putting it in the cloud. We need to account for any potential outages from either our perspective or the cloud provider's perspective as well. This is, again, where serverless may shine because these serverless technologies have this built in by default because the cloud vendors are doing this to them. So they're eating their own dog food, if you will. They're trying to tell you, you need to be doing this scalability and redundancy. We're trying to lure you here because we offer this solution. So they're going to be doing that themselves because they have a reputation to uphold as well. They need to have their services available. So, use their blood, sweat, and tears to your advantage here as well, if that's something that interests you. But we're going to cover more of these other security caveats here in a second, once we, again, talk about the database side of the house. Database needs their own scalability and redundancy also. So moving to these cloud native services would be a huge win. And again, my pain points have always been with databases, managing the database itself, the database cluster, the operating system for the database. So again, pushing as much of that to the cloud vendor. If you trust them to take care of it for you, then certainly wouldn't be a bad thing here as well. And a lot of the things that we've talked about with scalability and redundancy are simple, make the right selection when deploying the service and you should be good to go here. All right. So now shifting gears to the some more security discussion here and talking about layer 3 and 4 protection. So we have a couple different options for us, and one rather new one that I'll talk about on the next slide coming up here to help limit the exposure of our systems to would-be adversaries. It never fails that during Sec 488, when I'm teaching that, or even when I teach Sec 530 and that defensible security architecture course, we talk about, Shodan. Shodan is a great tool to self-assess, right? You can put in your company name or put in your IP space, and what Shodan is doing on a regular basis is just scanning the internet, trying to grab banners from listening services and present some kind of information about what it's finding. Now, again, attackers love using this service as well to try to discover if there's a new flaw with this particular version of this software. They'll use Shodan to try to discover, use their work instead of scanning themselves. Consult Shodan and say, show me all the Apache version 2.4. whatever, right? There may be a flaw with this. So you don't want to be exposed that way. So limiting the access to your environment, if it doesn't need to be made, certainly a huge win there. But it never fails when I teach this class and I want to bring up something like Elasticsearch, for example. See how many Elasticsearch databases are out there that are being hosted and facing the public internet, which is typically a bad idea. It never fails that the top 4 or 5 vendors that show up are all cloud vendors. Now, that's not the cloud vendor. That's customers of that cloud environment. So that tells me that a lot of consumers in these spaces aren't paying close enough attention to things like security groups, network ACLs, even their own host-based firewalls to limit traffic to these sensitive services. And we need to be doing this. We definitely need to be doing this because they're going to discover these services very rapidly. If the attacker doesn't, Shodan will within a matter of days, and it will be searchable now. So all of your dirty laundry will be out there for those to find. So controlling at the very least layer 3 and 4 traffic is a huge win here. And I give an honorable mention here to VPC endpoints. What those are essentially used for. If you have an instance within your virtual private cloud, whether it be an AWS, Google, Azure, you name it, right? Many of the big 3 vendors at the very least offer this type of solution. And they need to talk with another cloud service. That typically could go over the public internet. If you want to limit that and force them to use the backbone network of that cloud provider, you can look into something like VPC endpoints, which it literally puts a private endpoint inside your VPC. So now your instance or virtual machine will talk directly with that service over the backbone network instead of the public internet. So for more sensitive workloads, would certainly be a very good idea to implement something like that. All right, but beyond layer 3 and 4, this is where, again, it's perfect timing for this forum here. AWS brought out their network firewall offering. This is the breath of fresh air to me, because typically if you want to do some very creative things with application inspection, yeah, you have like your WAF, for example, but if you've got some very unique applications and unique payloads traversing through your network and you want to inspect or block based upon those payloads, you had to shove that data through another instance that was acting as a network appliance. But now we see some more cloud native services giving us this capability where we can now start to look beyond layer 4, looking at the payload itself and making some kind of determination that way. So this network firewall gives us the ability to block traffic based upon a few different things, as you see here. The source IP and or port, destination IP and or port, as well as the protocol. They call that the 5 tuple. So you can create now more robust firewall rules to block or permit traffic based upon those 5 details there. Also, though, you can block based upon or allow based upon domain names, which is very unique here also. Again, looking more at the layer 7 or the application layer here. And then the one that really hit home for me that I loved seeing this, now I can start putting some of my IPS, my intrusion prevention system rules into the network firewall. And now as it's seeing this payload traversing, I can, again, use these Suricata rules to block or allow that traffic. That's extremely powerful from a cloud native service. I don't have to rely upon, again, shoving my traffic through an instance running these tools. It's natively able to be used within AWS, which is very, very cool. However, again, through creation of my blog, I realized very quickly that does require some re-engineering of my environment. It's not just turn on the network firewall and it'll handle it from here. You do have to re-engineer your traffic flows and traffic patterns within the VPC itself. So some routing table updates, more isolation using subnets and so on need to come into play. So you do have to put on your engineering hat and your architect hat to make this, this network firewall work for you in your AWS environment. But really, really cool stuff. I was glad when I saw that, which prompted that blog post. All right, so what about the web payload now? We saw some IPS capability in that network firewall, but we can take it a step further and start deploying what's known as a web application firewall, or a WAF. Again, we can certainly do that by putting another instance in front of our web instance that we're currently running at this point, or yet again, we see another cloud service. In AWS's case, it's going to be AWS WAF. And when we're configuring these WAFs, we have a couple different approaches we can take. The one that's most often used, to be quite honest, is the deny list approach, where we have known bad. A lot of the cloud WAFs can ingest rules. Another OWASP project is their core rule set. They have what looks like known bad. You can ingest these rule sets. If the attack comes through this WAF system and it matches one of these rules, it's going to block that traffic. But attackers can, of course, evade that. If they're using an unknown technique or a new technique that doesn't quite match that rule, it'll be allowed to be passed on through. The more difficult yet more robust way to do this, however, would be to create an allow list approach. This is where we have, here's a rule set for all the known good traffic that's expected to go to my backend web server. Anything that doesn't match these rules, block this. So you can imagine that involves a really good relationship with your web developers and a lot of watching the network traffic and knowing what that normal happens to look like in your environment before you can start implementing these allow lists. It is a lot of work up front, but much more robust, blocking that traffic, that bad traffic from reaching your web application. All right. So now we've got all these great services, a couple, and this is just the tip of the iceberg, by the way. I only had 35 minutes. I can't cover everything you can do in AWS from a security perspective. But now that we've got a couple unique components running in our environment, we need to, of course, monitor this. So this data is residing everywhere. We have data on our web servers themselves. So a lot of the GET requests, the posts, any errors that happen, and of course, the underlying operating system logs all on that web server. We could have some data in AWS CloudWatch. We could have data pushed to AWS S3, depending on how our services are configured to push their log files. So how do we wrangle this data? You know, the worst possible solution for an analyst, so for any analysts listening, I'm preaching to the choir here, the worst thing you can do to your analysts is have them have to dig in through multiple dashboards. So if you're multi-cloud, for example, I have on-premise systems. So I might have a SIEM on-premise. I have Azure, for example. You know, I did say that dirty word during this talk for those that are AWS fans. So you might have a presence in Azure to where now I have all my data there. I have to then pivot to. I have AWS data. I have maybe some SaaS provider data. A much better thing for your analysts, of course, would be to wrangle all that data and push it down to one, again, buzzword bingo here, and I hate using this word, single pane of glass. So they can do their day job all in one platform. So there are, of course, going to be ways that we'll talk through to make this happen. Okay. So as I said, a lot of these services can send their data in AWS to CloudWatch and or S3. So from there, though, what you can do is move this data to a more appropriate place if that's not the ultimate destination for that data. Not to say you can't go through CloudWatch to run down an attack. You most certainly can, but your analysts, again, may appreciate the data being in one place. So how do I get it there? One additional service that you could subscribe to is AWS Kinesis Data Firehose to push that to your third-party product or to some other product, if you will, to get that data there. Also, another key component to CloudWatch, now we're kind of sticking with the CloudWatch monitoring here, is yes, I'm sending all my data to CloudWatch, but from there I can have CloudWatch generate what's called an alert. So if I see a bunch of log data, that's great, but I may be able to correlate certain logs or say, if I'm seeing so many logs in a certain amount of time, generate an alert. I may have some malice happening within my environment. And then from there, this is where we can start to revisit some automation techniques, where if an alert is generated, what else can I do in my cloud environment? I could kick off, say, a Lambda function. So just a really quick case study or an example, I'll say. So let's say you have a user that's just, logging, someone's attempting to log in as your AWS user over and over and over and over again. A bunch of denies are happening. That's, of course, going to be captured in CloudTrail, which can send that data over to CloudWatch. So I can set up an alert looking for that, saying, yep, looks like someone's brute forcing or running a dictionary attack against my AWS user account. But what happens if after a long series of denies happen, and then we have that eventual permit? It looks like that account was successfully logged into, that brute force or dictionary attack was successful. So I can generate some kind of automated response to that to say, if I see a bunch of failures followed by a success within a finite amount of time, I'm going to consider that breached. I'll do something like kick off a Lambda function, which will remove permissions from that user. So yes, they're in my cloud account, but all the permissions were stripped. So we did some kind of automated response at that point. So you can be very creative. The sky's the limit when it comes to the automated responses within these cloud vendor environments, which is great stuff. Okay. So one of the remaining gaps, though, we have here, again, I left networking ever so slightly, but now we're going to come back to networking really quickly because the gap that we currently have is, yes, we're doing a lot of prevention at this point. We have the network firewall doing some detection and prevention for us, but what about the rest? What if, all of our defenses are evaded, the service didn't catch the would-be attacker breaking into our environment? How can I get even more insight into that network traffic that's happening within my environment? Early on with cloud vendors, that wasn't a possibility, where you just simply couldn't see that payload until it arrived at the host itself. And then you have to do some kind of monitoring at the host, which could get very expensive very quickly. Doing monitoring on every single instance in your environment, it's a lot of software to run. That's a lot of agents. That's a lot of management. But now we have things like VPC traffic mirroring, to where we can get back or get closer to those on-premise IDSs where we're sniffing traffic right off the wire. Now, there, of course, going to be some setup involved here. So you have to configure a couple different things. One of those things being a mirror source, which is essentially, what do you want to mirror in your environment? What do you want to capture the traffic from? Now, this is going to be something that's awesome in the cloud, which we couldn't selectively do nearly as easily on premise, because typically we'd have like a span port on a switch and we'd pick which switch ports we want to monitor. But in the cloud, it's as simple as saying, I want this elastic network interface. I want this to be my mirror source. So it could be a critical system, could be all your systems. It's really up to you what you want to choose as your source. But on the flip side here, you have to also choose, well, where am I going to send this data? Where is this data going to be replicated to? That could be another instance in your environment acting as an intrusion detection system. So really cool stuff to be able to get that network payload now and run those network security monitoring tools in our environments. Now, of course, we got to keep our servers up to date as well. So just I know this is kind of a no-brainer nowadays, to where we're moving into the cloud. We get things automatically deployed for us using, like with our auto scaling, for example, it's based off of a known good golden image, but we got to keep these things up to date. So a couple different techniques of doing that. Yes, you could do a rolling redeploy of systems, which is pretty easy to do in the cloud. So if you update your gold image, for example, to be more up to date, have more embedded updates or hardened security settings, you can do a rolling redeploy of those systems. You can subscribe to other services that the vendors provide you as well. In AWS's case, that's their patch manager service, which is within Systems Manager. So again, just the big thing I wanted to mention here is, because you're in cloud, you still got to keep things up to date if you're managing the systems or the applications yourselves. All right. And the final piece, I know I'm not running long, but I'm getting really, really close to where I wanted to cut off and take some questions. IAM. So the reason I put this at the very end is because all that stuff that I talked about is all well and good, but if you're not handling IAM, and there's a reason why we make this an entire day, the first day of Sec 488, if you're not doing IAM properly, it's game over, right? If you lose your root account to an attacker, if you lose an administrator account to an attacker, it is essentially game over. All of those prevention and detection mechanisms you put into place can easily be stripped away. They can get at anything within your cloud account. So super, super important that IAM is first and foremost taken care of and regularly audited, and just making sure that you've done least privilege to the best of your ability in your cloud environments, or it again could be game over very quickly. And there are some other third-party tools that can help out with the management of IAM, such as cloud access security brokers. They can look at things like user behavior and at least tip you off to say, we've got some suspicious activity within your cloud account. So it wouldn't hurt to have a second set of eyes here, right, to do some more automated analysis of your environment. All right. So in conclusion, I talked about a lot of things very, very, very quickly. Welcome to Sec 488, by the way. We do the same kind of thing in that course, where we're just moving from topic to topic to topic. There's so much to talk about in cloud. It's not as simple as just saying, yep, point your systems here, deploy them here, call it a day. There's so many things to be looking out for. And I just started to scratch the surface in this talk here. So hopefully you got a lot out of this. The things I want to are highlighted here on the slide or bolded on the slide. Do the research. Use the best service that you possibly can. That's something that's really harped on whenever you're going for any AWS certification, for example. They really, really want you to be paying close attention to new services because stuff changes very rapidly in the cloud. You may be doing something that's not the best for your organization. So do the research. If a solution doesn't exist for you, the beauty of the cloud is their APIs, their application programming interfaces. If a tool doesn't exist for you, write the tool, right? If you have the capability or the team to do that, they make it easy. They make it easier, we'll just say in this case. And we definitely need to be doing monitoring in cloud environments, not just from the networking perspective, but again, that IAM is super, super important to pay close attention to, all right? So with that, I think the last thing I have is if you want more of that great stuff, again, tip of the iceberg, we've got several courses throughout the cloud curriculum, as I'm sure Frank is going to talk about throughout the sessions here. So again, I'm not gonna tell you which one to take, but I've got, of course, my preference here. And there's some contact information for me. Reach out on Slack if you need more or want more. I'll be taking some questions now, as well as in the Slack channel after I'm done here. So I'll turn it back over to Frank.
Yeah, Ryan, awesome presentation. We do have quite a number of questions. So, definitely some of them will need to be taken in the Slack channel here, but let's see how far we get here. You talked about this a little bit already, but any recommendations, other recommendations on open source tools for network security monitoring in AWS in particular?
Not to my knowledge. I mean, normally what we were using in my last environment was your typical third-party vendors that do a lot of like SIEM work, for example. Not going to name the vendor, but they have a lot of great integrations into those cloud environments where you can pull that data down and do the analysis within the SIEM that you already have. So that's, of course, going to be one option. And there are plenty of auditing tools that audit the cloud environments as well out there. Just again, off the top of my head, I don't have too many to really speak to. Again, just in my experience. So yeah, nothing to really add to that other than saying that there's plenty of open source tools out there that can give you some additional insight into those cloud environments.
Mm-hmm. And a little bit more of a detailed question here is, do you believe the IPS can protect web servers from the more prevalent layer 4 and above attacks versus the more specific focused WAF solutions that you're talking about? What do you recommend?
So they're I don't want to call them one and the same. WAF, I would consider like a more specialized IPS where they typically will have rules that are very tailored to web applications themselves. Not to say, but IPSs can do the same type of thing because at the end of the day, they're just looking at the payload. They're just looking at it a little bit differently where with an IPS, they're looking at raw bytes, right? In a lot of cases where they're not doing that deep of decoding that they may be doing, that a WAF may be doing. Because data can be sent in multiple formats. It can be compressed. It could be in base64 encoded, to where a WAF will be able to strip all that away and make more informed decisions based upon that. Not to say IPSs can't do that, but it does take additional tuning to make that happen on the IPS side of the house.
Mm-hmm, mm-hmm. Now, you were talking about monitoring, and is there a similar AWS service to Azure Sentinel?
For Azure Sentinel, I'm not aware of one, but luckily we do have some AWS personnel on the call here. I was going to say Security Hub, but I don't believe so. That's more of a checking in on configurations and compliance checks across your multiple AWS services. From Sentinel, though, from my understanding, of course, is going to be more of a Microsoft like SIEM type of solution that you can use within Azure. I'm not aware of one in AWS, but luckily we have the folks on the call here.
Yeah, exactly. I would like to hear the AWS folks chime in here on Slack, but with Azure Sentinel, like you said, that's a SIEM. They also have SOAR functionality, and there's not exactly the like equivalent on, as far as I understand, on the AWS side. It would be more. You mentioned the Elastic Stack earlier, right? And using the Elastic Stack in AWS would probably be similar.
Yep.
Now, in terms of logs, right, related to monitoring here, we'll just do another one or two questions here. What do you think is the most efficient way to pull logs from AWS into your on-prem SIEM? How would you go about doing that?
Okay, so my solution that I'm most familiar with that we had used was sending everything that we could to CloudWatch, and then from there using Kinesis Data Firehose to send that off to our on-premise environment. Of course, we'd have to have the networking in place and the reachability for that, but that's the approach that we took, and I would recommend as well.
Great. Now you mentioned there's a number of questions related to the new network firewall. How is the firewall different from the WAF? How is that compared to the firewall manager? How did all of these things with the term firewall in them differ, right? And how do they work together?
Right, it's a big question. So that's why I led into the story of, before we had to shove all of our network data through an instance acting as our next gen firewall, to where the network firewall services it doesn't do that for you. Because like I said, you have to re-engineer, you have to reroute your data through very similarly to how you would have done before. But it gives you a little more extended capability above and beyond what security groups and those network ACLs do, all in one nice package here between two separate subnets at this point. So it's looking a little bit more at the layer 3 and 4 data, as well as giving domain-based blocks and that Surcata IPS-based blocks as well. So
great.
To compare to the other ones, it's hard. It's apples and oranges, I would say.
Hey, we do have a question on serverless, but I'm going to table that just so everybody here listening knows. We've got another talk coming up here in about hour and a half or so, where Brandon is going to be talking all about serverless and serverless security. But Ryan, the last question that I'll end on here is that if you are moving to the cloud for the first time, or you're expanding the usage of the cloud, you've got your customer that you're working with, whether that be you as a consultant providing service to a customer or an internal business unit. What is the first thing that you would recommend? What else do you need to know in terms of kind of getting this migration planned out and on the move?
Yeah. So again, speaking from experience, what we would typically do is take whatever we're trying to transition into the cloud, or whatever application we want to build, just kind of break it into its small pieces and see, what are all the components to my application? Does the cloud have an equivalent piece of that? Can I start to leverage some of those cloud offerings to give those quick wins that we talked about before, like the scalability, redundancy, elasticity, all that good stuff? So breaking the application apart, seeing where I can start to leverage those moving parts within the cloud environment is really the first step to really understand your application, how it operates, and how we can translate that over into the cloud world.
Awesome. Hey, well, Ryan, great presentation. Everybody, let's give him a virtual round of applause. The other questions we'll have to take offline here or online in Slack. And yeah, we're going to go ahead and take a 6-minute break now, and we're going to come back at 10 past to resume with the next speaker. Thank you so much, Ryan.
Thank you.
All right, welcome back from break, everybody. Hope you had a good short break, got up, refreshed yourself, got a drink. We go ahead and introduce our next speaker here, who is Somasundaram Subbu. He's the category lead at AWS. Previously, a lot of experience in financial services at places like Scotiabank, BMO Financial, and he's going to be sharing with us today a little bit about security guardrails. So I'm going to go ahead and turn it over to you now. And while we're getting connected here, right, just a heads up for everybody in the audience, you know, it turns out that when you switch to presenter view, you're given the presenter ball. It takes just a moment to unmute and figure all of that out. So we're going to go ahead and give him a moment. Looks like
hello.
Yeah, someone. There you go. I can hear you now.
Yeah, just took a few seconds to unmute. Again, thanks for having me, Frank. This is a pleasure here. It looks like I accidentally clicked a couple of times. So yeah, Subbu, as Frank pointed out, I am a senior category leader in AWS. I've been with AWS for 4 years now. And during this time, I had the privilege to work with large enterprise customers to install their security. In today's section, I'll be sharing some of the challenges and solutions based on my experience working with my customers. And of course, as the title states, it's security guardrails for specific to DevOps. And as a customer who's trying to do DevOps, and the major challenge is how do I strategize my access management to the environment?
Hey, Soma, sorry to interrupt. You know, we're getting a little bit of static, a little bit of feedback here. We can hear you, but you know, it sounds like maybe there might be a loose connection or a little bit of static coming across here that makes it a little choppy.
Okay, let me get that fixed right away. Thank you.
Yeah, so while we're waiting for him to connect back, so just to give you a little bit of a heads up, the next talk after this is going to be all about serverless security. The one after that is about threat detection and incident response. And then we'll have another talk after that on monitoring and threat hunting. And we're going to close out the day with a panel with 5 different participants, a couple of which whom you will have not heard from up to this point in the session. So just a reminder also that this is the first ever Cloud Security Solutions Forum, and with SANS and AWS Marketplace. So we have that freely available book, 365-page Cloud Security book available. The link is in the channel and chat room as well. Suba, you want to go ahead and do a quick sound check again?
Awesome. Yeah. Does it sound better, or how do you feel now?
Oh yeah, that makes a huge difference. Thank you so much.
This looks like the old school wide view works better.
Yeah.
Okay. So thanks again. Thanks for the patience. Again, going back to the agenda, to begin with, I will explain the challenge with access management when organizations utilize DevOps as an operating model to run their AWS environment. That's one of the primary challenges we will talk today. And I will walk you through one solution which uses access guardrails to reduce risk and gain confidence. I will also dive a little bit deeper in one guardrail, which is the preventative guardrail. And at the end, I'll point to some of the options you have in AWS Marketplace to implement some of the access management solutions. Okay. With no further delay, let's start to dive deeper in the access challenge when it comes to DevOps and implementing in an AWS cloud. So looking at DevOps, one of the main purpose for DevOps is to enable organizations to deliver applications and services at a high velocity. I really need to underscore high velocity here. This speed enables organizations to deliver features to their customer faster and also compete more effectively. I think one of the core objectives here is the speed and time to market. I think that's one of the main purpose organizations started to adopt DevOps, and so that they can modernize faster, get features out faster to the customers. But if you look from a business owner's standpoint, the owner would like to ensure the applications has been built with the right level of security and compliance and delivered at speed with low effort and high confidence. The low effort comes with automation, high confidence comes with ensuring the reliability, security, and everything is maintained. In some cases, however, we noticed security has been implemented as a gated approach, where a human would be performing the review to validate if there is the right level of access and if there is the right level of security established. This approach would definitely ensure that security and compliance is established. However, it might slow down the delivery speed and increase the time to market. This becomes counterproductive from the DevOps model where they want to move faster, get features out faster at a higher speed. So now let's look at the same scenario when it comes to how it works in the AWS world. Here, the top bar represents the CI/CD pipeline that are typically managed by DevOps teams. The bottom green bar and the side blue bar represents the governance, management, and observability capabilities that are required to successfully operate an AWS environment. As a first step, typically customers start to provision their AWS accounts. This includes like baselining the account, like ensuring that the CloudTrail is enabled, config is enabled, and also having integrated with some of the solutions like access management, secrets management, log management, and also billing and cost management solutions. So Control Tower, AWS Control Tower is one of the services that provides this functionality to help customers to consistently provision AWS accounts and baseline some of these capabilities. The second stage here, the network deployment stage or foundational infrastructure deployment stage, this starts with deploying services such as VPC, which stands for Virtual Private Cloud, subnets, transit gateway, and other foundational network backbone that an application needs for communication or user needs to talk back to the on-prem services or to the cloud services within different environments. At this stage, some of the network security and API security components can also be set up to ensure the network security and perimeter security are well handled. This includes NACL, the network access control list, security groups, network IDS and IPS solutions such as Palo Altos, and also sometimes you may have third-party solutions that are implemented in a shared service, a shared network accounts such as. So once you have this account baselining and the network foundation set up, that's when the applications teams in a third stage, typically this can be full stack developers or the teams who manages their own resources, the AWS resources and the applications as a package to deploy and manage. So this could be a 3-tier stack team that they are deploying an Amazon EC2, EBS volumes, and Amazon RDS for their 3-tier stack application. Or this can be a serverless stack which uses Amazon's API Gateway, Amazon Lambda, and Amazon DynamoDB to manage their serverless application stack. Again, the set of applications that are deployed by this team could vary. For example, if your application team is managing a big data solution, they may be provisioning Amazon EMR, Athena, Redshift, and those type of tools and Amazon services. Again, this drastically changes by what the business is trying to accomplish. One of the critical factors that connects these are the access management layer. So the DevOps team has the right level of access to manage their individual resources or services that they manage. And the second part of it, for it to be successful, is the logging, so that you have the right level of governance, management, and observability established, so you can feel successful and confident in this environment. Now let's focus on the access management layer for today's session. Applying the right level of access plays a key role in the success of DevOps. The access for each of this individual pipeline, such as the account baselining pipeline, a resource pipeline, and a resource and application deployment pipelines and network pipelines, should be customized to ensure it has the access only to manage its resources that it supports. For example, a resource deployment pipeline should not have permissions to change resources provisioned by an account baselining pipeline. Similarly, a network deployment pipeline should not have permissions to update resources managed by an application teams or application resources that are deployed by and managed by a different team. So unless if there is a special case scenario where there is an exception where there is an incident response scenario that they have to manage a resource. In addition, for deploying these resources, often these pipelines are required to build their own IAM principles so they can manage their own automation for application and database access purposes. So for example, here you can see as a part of account baselining, the human access role and additional automation roles are provisioned as a part of these pipelines. Similarly, The resource deployment pipeline might be provisioning roles, access, and permissions for applications to access the backend services, or the data access for Amazon DynamoDB, Kinesis Stream, and Amazon EMR, and even interact with other application services hosted in same or different AWS environments. Now, what we need to have is, we have to, with this requirement in mind, one of the question is, how do you enable DevOps team to securely provision their application resources on relevant IAM principles? Hence, our challenge is to enable DevOps team with the ability to provision IAM resources required for their application stack, at the same time ensure the right level of security is maintained. That's one of our challenges that we need to solve. Okay, one of the solution is to enable an access guardrail for DevOps to reduce the risk of privilege escalation and enable segregation of duties. So the overall privilege acquired by a DevOps team is always under control. So let's start to dive deep here. This is a common diagram that illustrates the DevOps infinity band. It shows the different stages in DevOps workflow, such as plan, code, build, test, deploy, operate, and monitor. It also shows the different security controls and guardrails that can be implemented in each of the stages to ensure the appropriate security is implemented in the DevOps workflow. For example, applying a static code analysis in the build stage, or dynamic analysis in the test stage, and compliance checks in the monitoring stage. These are different security guardrails that can be implemented to ensure confidence. Well, let's convert this to access guardrails and see what are the options we have today. At a high level, we can break this down as a pre-deployment guardrail versus a post-deployment guardrail. The pre-deployment guardrails helps to ensure validations can be caught more proactively before the deployment is made. The post-deployment guardrails helps to prevent, detect, and remediate in a production environment in a more reactive fashion. But for us to successfully operate in an environment, you need to have both so that you can have the overall confidence. If you look from a DevOps engineer standpoint, as we said earlier, they need to achieve agility, and they may need permissions to perform build and deploy deployment tasks, right? So one of the foundational criteria is to ensure everything is codified and automated. So this includes infrastructure as a code and security as a code. At the same time, not just codifying is going to solve the problem. We need to ensure all the deployments are only done via the approved CI/CD pipeline and does not have other ways to change the resources unless approved by an approval process in an incident response scenario. Because once you establish a pipeline, then you have to reinforce the pipeline to ensure only the resources that are built by the pipeline are managed by the same pipeline. If you look from an access administrator point of view, one of the questions that's commonly asked is, how can they ensure the pipelines can only deploy the appropriate resources and meets least privilege access that's required for the pipeline, or the DevOps teams using that pipeline? Adding a preventative guardrail, such as a condition-based policy, allows changes to resources based on specific conditions, in addition to the role-based access control that's already been established. This could include adding attributes such as environment variables, product types, product names, or application names, etc. This provides more confidence that specific pipelines can only access its own resources and not someone else's resources. This is quite often a common challenge when you have an environment which is shared across multiple application teams. Now that we have seen the preventative guardrails, let's look at the detective guardrails. In this case, this helps to ensure the permissions deployed by the pipelines does not violate least privilege access. For example, the security as code can be scanned by tools such as CFNGuard, CFNNAG, and other linting solutions. I've built my own homegrown linting solution as well to scan these templates to make sure these permissions are at the right level. For example, if you see a permission that has a ***, which means allow all, that can be denied from deploying. If you have a permissions to manage unauthorized resources, for example, if someone is deploying an IAM policy, which allows to manage someone else's resources, then you can deny that. And you can also deny permissions for that makes to perform unauthorized actions, such as deleting a CloudTrail, turning off configure recorder, or deleting S3 bucket, which may have sensitive information. So these can be prevented in a directive fashion. Now that we have seen some of the controls from pre-deployment stage, now let's start looking at what's happening in the post-deployment stage. There can be preventative guardrails in the post-deployment stage as well. Unlike the preventative guardrails that are put in the pre-deployment stage, this is primarily focused on controlling the actions that are specific to this pipeline. The post-deployment guardrails are global controls that are applied at the account level or environment level, and it applies to all the IAM principles unless if there is a conditional exception established. So this ensures anyone, any pipeline, or any users accessing this environment can be protected. So some examples could include having a service control policy, often referred as SCP, that are applied at an organization unit level, root account level, or account level. You can also use permissions boundaries that are forced to apply to a broad set of roles based on some conditional criteria. That's also another option we have seen. So these helps you to prevent the production environment. Okay, now let's look at what we have from a directive controls perspective. So you can also apply similar directive controls, but that's as continuous scanning tools that can scan the environment for access compliance. You can set up your rules to ensure the least privilege access is established for all the IAM principles that are provisioned in this environment. You can also scan to detect for unused credentials and delete those credentials. If there are access keys and secret keys that are provisioned and you do not want that to be present in the environment, you can remove those access keys and secret keys. And if you see there are rules that do not follow corporate standards, corporate naming standards, or it's not assigned to the right centralized identity tool or access management tools, you can remove those rules that are not properly managed. So this can be continuously scanned, detected, and remediated. So last but not least, the responsive guardrails to perform the automated remediation when a violation is identified. Of course, this is also mandatory for you to be successful in a DevOps world, because once you detect something, you really want to remediate as well. However, this type of remediation has to be done cautiously so that when you're confident these remediation automations work or effectively without shutting down a production environment, you can implement those remediation automation. Some of these remediations can also be performed manually, such as when you have like incident response playbooks and runbooks. Some automated remediations examples could include decommissioning an unused credentials that's been sitting there for many days and removing roles that are never used. So those things can be automatically remediated. Now that we saw the overall view of different type of guardrails, starting from the preventative detective in the pre-deployment stage, preventative detective and responsive in the post-deployment stage, we can start to dive deep on one guardrail here. Here, I'm picking the preventative guardrails, and I want to walk you through how it's implemented in some of the customers we had today. Okay, I'm sorry, there's a delay in the click. Yeah, so let's dive deep on this specific preventative guardrail in a post-deployment stage. So first and foremost, we need to start to group the controls that needs to be established in an organizations. This starts with organizing the controls into dedicated groups based on your business needs, based on your organizational structure or your application architecture or application needs. It could be compliance reasons too. For example, your business may just be operating in a specific set of regions or countries, or you're required to operate in a specific region to meet for compliance requirements. Similarly, you might be required to use only a specific set of services that meets your requirements or your corporate standards. So these can be grouped in their own buckets. Third guardrail is to protect the shared services that are applicable to many applications. For example, log aggregation, network hub, transit gateway, and other similar services should always be turned on and it needs to be protected. These are the shared services that needs to be protected. Guardrail 4 talks about the governance resources that should be protected. This can be CloudTrail, Config, GuardDuty, and other vendor applications that are deployed in an EC2 instance. That needs to be protected as well. For example, you may have a Palo Alto running in an EC2 instance. We want to make sure no one turns off that Palo Alto instance. So those things need to be protected as well. Fifth guardrail ensures protection for data plane access. This ensures that no developers or engineers are able to access to the data layer. So you can control access to, for instance, S3, or someone's trying to make a backup of an EC2 or EBS volume. So you can have those protections in place. Guardrail 6 focuses on restricting some privilege actions that can be an elevated permission. It can be detrimental to the environment, or it can be detrimental to the actual data itself. For example, someone is trying to delete an S3 bucket or removing a production instance that's up and running. So those things can be prevented by ensuring those controls are denied, or those actions are denied. Having these multiple set of guardrails, one thing that it does is it allows the DevOps team to manage their own environment, and it actually gives more confidence to the access management team. Following shows some technology options that you can utilize to apply these guardrails. For example, we can use SCPs all the way from guardrail to guardrail 3, and you can use SCPs or permissions boundaries for guardrail 4 and permissions boundaries for 5 and 6. Again, these technology options may change over time, or you may have new features and advanced features that you can apply to get the same controls that you would like to achieve. So always be prepared to update these technologies when new technology becomes available. So when you build this architecture, you have a mindset that you are able to change these guardrails in a more ad hoc way or a more modular way, so it doesn't impact the production or running systems. So you can change it quickly and to an advanced feature that's coming up in the future. So a common question that I often get is, who should be managing these guardrails? It really depends. It really depends on the organization size, organization structure, their cloud and DevOps maturity, and the nature of their business. This shows an example. Whatever I've displayed here is just an example where a cloud ops team, which quite often is referred as Cloud Center of Excellence team, they can be managing the guardrails that are primarily associated with infrastructure components, because they are provisioning the infrastructure and foundational account stuff. So they can manage those foundational guardrails. And the security teams can manage guardrails associated with the access control in the specific use case, so that the security team can feel confident that these controls are already in place, these guardrails are already in place, so they can confidently allow to nominate a delegated administrator within each DevOps, application DevOps team, or we can call it 2 pizza teams in Amazon, to manage their own access controls, to provision their resources within their environment. Okay, let's validate this. Okay, you could ask me, hey, how can I make sure this works? Let's assume that a user managed to get full permissions to the environment, like a star. These guardrails, it looks for if this environment has a region restriction, it automatically denies it. It automatically denies service restrictions. It protects the shared services. It protects the governance resources. It protects the data layer. It protects other privileged action. And then if you can have a resource tags that controls the resources that are deployed in the environment, that can also be applied. And finally, this specific user will only get the residual permissions it comes at the end of the access. So this enforces confidence and also reduces the blast radius in case of a compromise. And in a normal case, it's even better, because we have other guardrails that we have to go back and see. Let's not forget, we walked through a whole bunch of guardrails here. What we have seen here is only the preventative guardrails. If you combine the preventative and detective guardrails, which is already plugged into the DevOps pre-deployment stage, and you already have detective and responsive guardrails in the post-deployment stage, if you combine this with all the other guardrails, this will increase the overall confidence of this environment. These guardrails removes or reduces the manual reviews and approvals, and also allows the DevOps teams to focus on deploying at speed and scale. So that's why this guardrail-based model just allows you to give more confidence and reduces the number of gates that you need to establish. And of course, in some regulated environments, there may need to be some level of manual checks that needs to be done. So that can be minimized and allow the DevOps teams to move a lot more faster. Okay, so now that we have seen the number of guardrails and how it can be used, we just covered quite a bit, and hope you leave this webinar feeling confident about the next steps with security and access management strategy with DevOps. Some products discussed today and more are available in the AWS Marketplace. AWS Marketplace is a curated digital catalog service that simplifies software discovery, procurement, provisioning, management through features that speed up product evaluation, improve governance and cost transparency, and enhance control over software spend. We have a broad and deep selection of security solutions offered by hundreds of independent software vendors, spanning infrastructure security, logging and monitoring, identity access control, data protection, and more. So this goes back to the different guardrails I mentioned. You have preventative guardrails, detective guardrails, responsive guardrails. You might be able to find solutions for each of these guardrails from our marketplace. AWS Marketplace can enable you to receive quicker time to value, and thus the ROI with your third-party solution. Recent third-party research found that it takes an average of just 27 hours to find, buy, and deploy a solution through AWS Marketplace, compared to 52.4 hours through other procurement sources. That's an average time savings of 49%. This research also uncovered how AWS customers, such as yourself, felt about their AWS Marketplace purchasing experience compared to other sources. As you can see on the right, a few of these highest rated benefits include cloud readiness of the solution, time to value, and return of investments. AWS Marketplace is supported by a team of solution architects. A number of them spoke today, security experts, product specialists, and category leaders like mine, and other humans to help you connect with software and resources you need to prioritize your security operations in AWS. So you can ask, how do I get started now? There are a wide variety of security solutions available in AWS Marketplace. I've listed some of the key vendors here. Many of them offer support for creating efficiency within your SOC. When you're ready to buy, flexible pricing options such as free trial, pay-as-you-go, BYOL, and seller private offers help you to unlock best prices and meet budgetary needs. I would like to also announce a new AWS private marketplace feature that just launched. With private marketplace, buyers can curate a catalog of approved third-party softwares available in AWS Marketplace, allowing their organization's end user to purchase software within their internal policies and procedures from AWS Marketplace. Private marketplace remove the need for blanket security controls for procurement and unlock the ability for end users to subscribe to third-party software pre-approved within AWS Marketplace. AWS Marketplace now enables buyers to programmatically manage their private marketplace using a set of public accessible APIs. There is also multiple deployment options, helping you to customize software provisioning to fit your security policies. This is very applicable for the DevOps world. AWS Marketplace helps you to customize and provision software the way you need it. Here are just few we would like to highlight today, including SaaS, Amazon AMI, CloudFormation templates, and Amazon ECS way of provisioning. Okay. Again, we saw a lot today. I think I want to save, I'll give you a lot more time for questioning. Feel free to ask the questions that you have. I'm happy to dive a little bit deeper. And my email is here. Feel free to reach out to me if you have some detailed questions. I'm happy to provide my experience and share some feedback to you.
All right. Hey, thanks a lot. A lot of great information there. We have a few questions that have come in here. And you talked about this a little bit in terms of kind of your logical flow earlier, but what recommendations do you have for change management within DevOps in terms of the classic change management process and versus how DevOps is working now in terms of continuous development? What would you suggest to kind of bridge that gap?
Yeah, I think change management, again, and now there are some modern ways of doing change management. I think we have, I've seen teams build solid Git workflows with peer reviews And like I pointed out, there are automated guardrails, like automated tests that are built. I've seen teams, every time they write a user story, they know that this is a specific capability they need to build. For that capability, they work with the security teams to build the security tests that are required for this capability, and also any unit tests that are required for this capability. So when they build this pipeline on the capabilities, they automatically start to work with security architects and others to build these test capabilities. So that kind of helps with the overall change management process. And in some cases, they integrate with change management tools to make sure those tracking is always enabled. So there is an entry for every change that's been made.
Great. Next question. You talked a little bit about the different teams. So you've got the DevOps team, the kind of the ops team, the security team, the application teams. What do you see in terms of kind of the trends, and how do organizations go about building out that RACI, who's responsible, accountable, consulted, informed, and dividing those shared responsibilities? Can you elaborate more on that?
100%. Yeah, I think this is where, like I pointed out, this really depends on how the type of the business they are in. I always work backwards from what is the customer trying to achieve as a business, right? And are they really trying to modernize so that they can quickly move features to their customers, or are they trying to just lift and shift, migrate their apps to the cloud? So every business has their own objectives. So aligning with the objective is number one. And second thing is the maturity. And like you pointed out, I think if there is an organization that has a smaller footprint, they want to work on DevOps world, the structure is going to be very different. If the whole organization is moving towards a DevOps world, and now you're talking about centralization, these guardrails can be centralized. For example, the Cloud Center of Excellence team, that can be centralized. So that's where it really depends on the org structure. And I've also seen some organizations try to adopt a product-based operating model. If they are adopting a product-based operating model, then a previously model such as service-based operating model, so it might change drastically how you structure your org. And I'm also seeing versus centralized versus decentralized approach, and it really varies based on the business and the org structure.
Yeah, makes sense. The next question here, in terms of, you're talking about the marketplace, AWS marketplace. Is there any kind of guidance, templates, some sort of standards on what are the cloud security requirements that help you decide between a AWS native service versus a product that's available in the marketplace?
Yeah, so I will follow up on that. I'm not sure who has a question, so I'll follow up on that question. Feel free to email me. I'll get back to you with more details.
All right. Next question related to the guardrails. A couple of questions related to that is, you had on the slide, you mentioned SCPs, service control policies. Are the guardrails typically implemented using service control policies? Yeah,
like I pointed out, so these guardrails can be done by a service control policy today. And in future, if you find another way to do it, you can do it differently as well. So again, I've been with AWS for 4 years, and SCP was not there back then. So we ended up using a different technology to achieve the same control. So again, you may be shifting forward based on the new features and technology that's available. And based on the experience from last year, I've used SCPs. And again, there may be new features that's coming up, and you should be able to use that as well. So that's where the modularization come in play, how you group those controls, modularize it, deploy it. When there is a new feature or new technology that becomes available, you can push the same control in a different way. Again, it's all following DevOps principles.
Yeah. In the case of a violation of a guardrail, how are those typically detected, and so that they could be remediated?
So, so again, that's now diving a little bit deeper on the technology space. Now, there are different ways to detect it. So you can use native solutions like CloudWatch events, config rules, and we also have solid third-party solutions like Dome9. They can continuously scan the environment. And again, now as a team, as a customer, you are required to put the rules in place saying that these are the violations that I consider in my environment. When these rules are established, so those rules can be scanned in the environment, and a notification can be sent to your ticketing system or SOC or email, whatever tools that fits your needs. And we have SNS topic to plug in to get those notifications as well.
Great. Hey, very last question. I think this will be a quick one. You mentioned the Cloud Center of Excellence earlier. Is how many people do you typically see in a Cloud Center of Excellence, and who are they? What do they do?
Yeah, so Cloud Center of Excellence is when an organization starts to get to the cloud, and they may have a very small group of people who are the experts in the cloud. So they starts to identify the top security experts in the cloud space, top reliability experts in the cloud space, top infrastructure experts in the cloud space. They bring them together and build this cloud center of excellence. And as a matter of fact, I used to be a part of this cloud center of excellence when I first built a cloud for a previous organization where I used to work for. And we build the cloud foundations together as cloud center of excellence. And in this process, we also try to train other teams and make resources available so that they can quickly catch up. So that helps with the organizational transformation. So the Cloud Center of Excellence helps to move to the cloud and eventually train the rest of the organizations to start adopting the cloud as well.
Mm-hmm. All right, well, excellent. Thank you so much for your presentation, everybody. Let's give him a virtual round of applause. We have the Slack channel available as well for any further follow-up. And yeah, with that, thank you very much.
Awesome, thank you so much. Thanks for having me.
All right, we're going to go ahead and introduce our next speaker now, who is Brandon Evans. Now, Brandon is the author of the SEC 510 SANS class, which is all about public cloud security across various cloud providers. And he's an instructor for the SEC 540 DevOps and Cloud Automation class. So with that, I want to go ahead and hand it now over to Brandon. Brandon, it's all yours.
Thank you so much, Frank. So thank you for attending the session. Thank you for attending the event writ large. My name is Brandon Evans. As Frank has mentioned, I am an author of SEC 510 Public Cloud Security, AWS, Azure, and GCP, as well as an instructor and course contributor for SEC 540, Cloud Security, and DevOps Automation. And in this session, I'm going to be talking to you about a broad amount of topics regarding serverless and how serverless technology both can actually help in the security realm and how risk is changed within the serverless world as well. The two courses that I teach for, I think there's a slight delay between the transition and the slides. Okay, there we go. Hopefully it stays on the slide. This material that is sampled from SEC 510 and SEC 540, both of those classes are a part of the SANS Cloud Security curriculum. There are a large number of courses that are in the Cloud Security curriculum, many of which have come out just in this year, including SEC 510, the course that I authored. So if you'd like to learn more about any of these classes or any of the classes in SANS writ large, as I'm also a student of SANS, I'd love to talk to you about that via the Slack channel after the presentation. So a little bit about me. Like many people in SANS, my day job is not SANS. Most SANS instructors are practitioners in the field, and I am no exception. I work for a company named Asurion, a very large company that nobody is aware of. And the main reason why that is we provide white label solutions for a lot of larger companies. So if you have an insurance plan for your cell phone and your cell phone is provided by AT&T, Verizon, Sprint, and many other carriers, well, guess what? You are an Asurion customer. I help out with the securing of all the applications that power our services and our products. And I do this by being a trusted advisor, giving the knowledge that I have regarding security to the developers and mentoring them in that area, as well as building secure pipelines and much more. I mentioned my involvement in SANS, and here's a little bit of my background. But the main thing that I want to focus on with regards to my background is I come from a developer background. I've been a developer for a lot longer than I have been a security practitioner. And that really informs how I talk about security. Oftentimes we see how security and functionality trade off with each other, or at least security and agile development can oftentimes trade off with one another because we don't have enough time to do security work. We're too busy delivering features. And I think a lot of security people have the reasonable reflex to say, oh, here's a new technology that the development team wants to adopt. That must be insecure because it's not the tried and true paved road of what we are used to for developing and maintaining applications. So I want to get my bias out there right out of the gate. I love serverless technologies. I love them as a developer who does not like staying up all night waiting for a call saying that I have to reboot a server in order to restore our service. I like that it allows me to focus on what I care about, which is building code for my organization to manage the business need of the company. We don't get any bonus points for having an elegant set of virtual machines that run our code. All that matters is that our service is being fulfilled. So by having a serverless technology, I can focus more on that. And probably most importantly to me, at least today, is that I also like it for security. serverless has some intrinsic benefits to it with regards to security. But with any technology, especially a new technology, there are also some misunderstandings of the technology that can result in security harm as well. So in this talk, we're going to talk about both of the sides of the equation: the good, the bad, the ugly, how we can transform the ugly into the good with further understanding of the technology and how it works. So before we get into that, let's first and foremost talk about what serverless is in the first place. There are competing definitions of what serverless is. Well, serverless originally described something very different than it did today. It referred to any technology that allowed for you to focus on your development by outsourcing the outside services to some other company that would maintain the servers that ran those services. So instead of running my own server, running MySQL and having to worry about patching and maintaining that server, I can outsource that work to a tool like Parse or a tool like Firebase. Now, I wouldn't necessarily recommend to specifically outsource your database to Firebase, and I wrote an entire white paper on that subject, which I've linked to in my Slack channel, but nonetheless, this would be considered back in the day a serverless technology. Same thing with authentication. Why run my own authentication server if I can outsource this to Auth0 or to AWS Cognito and have my developers focus on what really matters, not the operation of those servers or those services, but focusing on their code and how the code interacts with those services. So that's the traditional way of thinking about serverless. The new way of understanding serverless is actually just an evolution of that previous idea. If we do not want to have to worry about maintaining servers for services that we didn't write, why would we want to maintain servers for our application code? That does not seem consistent with our goals. We want to focus on our application, not on operations. So a bunch of smart people invented very similar solutions that solve that exact problem. Serverless technology that allows for you to define your code, tell a platform when to run that code based on an event or a schedule, and then as a result, properly execute the code necessary to support your organization. You don't care about which server it's running on. You don't care if it's running on the same server consistently. Perhaps the provider will recycle the servers behind the scenes. And when I say servers, I'm generically referring to anything that can host an application. That could be a bare metal dedicated server, that could be a virtual machine. But in the world of serverless, we're normally talking about containers. We have a container that is spun up to deal with a particular workload based on an event, and then it goes away eventually. It's an ephemeral environment. The main providers of such a serverless service are the main cloud providers. AWS by far being the leader in this space, having come out with AWS Lambda far before the other two providers. And I don't think it's even controversial to say it's the most mature solution in that space. And I'm not just saying that because AWS's sponsorship of this event. That's truly my opinion. But there are other alternatives, such as through Microsoft, through Google, and they both work. And we are going to talk about those ones as well. There are just a lot of differences between the three of them. And you typically are not going to run an API server to front these functions either. You're going to potentially use a managed service to support the execution of these functions based on an API call. So let's talk first and foremost about what the benefits are of serverless to DevOps. DevOps teams love this for the same reasons I mentioned earlier. They don't have to provision and manage servers. Applications can automatically scale because these serverless platforms can provide additional functional containers for the amount of traffic that they are trying to serve. The expenses are all based on your usage. And there's kind of a misconception about that I'll briefly refer to. A lot of folks think that serverless is unbelievably cheap. And the reason why they think it's unbelievably cheap is they look at the AWS Lambda billing page and they focus on the first part of it, which is absolutely true. You can invoke a function 1 million times, and I believe spend 2 pennies on those 1 million invocations. But that's only one half the equation. You also have to worry about execution time. You have to worry about how long your functions are actually executing. But if you're using serverless in a reasonable way, for the way that it was designed, for short running pieces of code that do something and then go away, you can save a lot of money through that paradigm nonetheless. Fault tolerance is, you gain a lot of fault tolerance here because again, you're not maintaining the servers, and combined with that API gateway service we referred to in the previous slide, you can purely run a serverless environment and satisfy all of your business's needs, which is amazing. Now let's talk about security benefits. And this is such a breath of fresh air to see a new technology bring actual security benefits. And it's totally true. Serverless means that our attack surface is smaller. There's less resources allocated to our serverless functions traditionally, and good function development would imply that you would write smaller applications or smaller functions that make up one bigger application. Probably the most important thing with regards to serverless is you're not responsible anymore for patching the server. You're not worried about whether or not malware has taken a foothold in your container running your function, because your functions are only going to run for a period of time. Now, it's a misconception that they go away immediately, and we'll talk about that, but nonetheless, you're not running long-running servers for potentially years. You're more likely running servers for about 6 minutes, let's say. And this last part is kind of a misconception, unfortunately. You do not get a new clean server every time. That may be how it's perceived by the public, but the function provider, the cloud provider providing this functional service, has discretion of how this exactly operates. And we'll talk about what we've noticed through our research is actually how they operate behind the scenes. Now let's talk about serverless security concerns. The biggest concern I think you should have for serverless is the same concern that you have for all applications. Application security does not stop being important just because you're running serverless functions. A lot of people perceive this differently. They say, oh, this is a small itsy bitsy function. It can't be doing anything seriously, so we don't have to worry nearly as much as in a giant monolithic application that has all of these different bugs in it. They're not the same kind of scenario. Well, they kind of are. I mean, your serverless functions are talking to customer data, to personally identifiable information, likely to application secrets such as API keys and cryptographic keys. We need to take these functions seriously. Just because a function can be used for something trivial does not mean it is used for something trivial. And there's also a lot of concerns regarding the management of functions. You may have excessive permissions for who in your organization can deploy a function for this exact reason. Oh, it doesn't matter. We can let our developers deploy functions to production with no oversight. No, I don't agree with that. I think you still need the same kind of oversight that we saw in the previous talk for our functions. And then it's just such a new technology that I think there's also a lot of compliance concerns because we don't fully understand everything that goes on in the serverless environment. And I hope that this talk will help demystify a lot of those topics. So one of the topics that we should be talking about for sure is that persistence matter. The matter of how long does the container running our function actually live? And the answer is it lives for more than a couple milliseconds in reality. It doesn't spin up, run the code, and shut down. And there's a really good reason for why that is the case. And the reason is developers would not stand for it because there's a lot of latency related to what's called a cold start. When you first load your function for the first time and execute it for the first time, it can take some time, especially if you're running your serverless function in a virtual private cloud in AWS Lambda, because setting up a VPC in the connection of VPC for a Lambda takes a little bit of time. Now, I know there's been a lot of improvements from AWS on this side, absolutely, but it still can take a while. And in many environments, I've seen functions take approximately 3 seconds to start up on a cold start. Now, you have to ask yourself, will your customer accept a 3-second latency for an API call? And it largely depends on what the API call is for, but I would notice it personally. I mean, if it takes 3 seconds to log in, that's not what I expect in 2020, especially for an application with not a significant amount of load. So you have to consider that as well. So because of this problem, the problem of cold starts taking a long time, a lot of these providers have the idea of a warmed up function, a function that has your code loaded and all of your connections set up. It's ready to go. It's ready to execute code. And what they'll do is they will keep the containers running your function warm for a period of time until they die off due to inactivity. And during that time period, you can have persistence. So we need to be worried about whether or not there is a vulnerability that would allow for persistence, or a vulnerability that would be able to exploit persistence, because these containers do not go away right away. We'll talk a little bit in this talk about application security. We'll talk about how it's important to still think about application security. There are some differences in how we operate with application security, but if you're following all the same practices that you would for monolithic applications, generally speaking, you will be all right. So there are a lot of resources that we want to reference with regards to serverless. The security community is moving towards understanding and developing resources for serverless. There's an OWASP Serverless Top 10 project. I personally know the two leaders of that project, really nice folks. I know that a lot of things have slowed down due to COVID, but there are still a lot of great resources out there. And there are several capture the flag kind of environments that you can test your offensive security skills in a serverless environment. So generally speaking, when it comes to best practices with serverless, specifically in application security and role-based access control, in those two domains, one of the biggest problems that we have on the application security side is how do we scan these functions with static analysis? Well, static analysis generally works by having context about how data flows from one part of the application to another part of the application. Well, what happens when you're in a serverless environment where all these functions are independent from each other from a code perspective, but actually do interact with each other via a web application or some kind of orchestration in a backend? Well, the answer is it's really hard to scan those functions. So one approach you may want to take is to create what's called a monolithic repo or a monorepo for all of your functions. I should probably say monolithic repository. I abbreviated repo, it's just so natural for me to do that. By having a monolithic repository where all of your functional code exists, you can get some more of that context that would otherwise be lost when you have completely independent functions. Role-based access control is still very important. Not only who is able to execute a function, but what can this function do? What services can it talk to? What data does it have access to? And we need to monitor everything we do not prevent explicitly. So it's going to take time for organizations to fully understand how this technology works, but hopefully this presentation can be a great starting point for you. And I can point you to other resources as well that'll help enhance that understanding. So in terms of security, not only does security have the benefit of not having long-running servers that run our applications, but you can also use serverless for security purposes. You can make it so that your access point for all of your functions are centralized using, let's say, an API gateway, an Amazon API gateway, or an Azure front door, or Google's App Services, App Engine. And you can also use serverless technology to do security automation. How many times do you have a script that you just want to run every so often for security purposes? Well, instead of running that script on your personal computer, why not run it in the cloud in a serverless fashion such that it is going to run only when the when the tool actually needs to run? You can save costs by not having infrastructure running consistently to do these operations. And we have a lot of examples in SEC 540 about how we can use this to enable our security in automation using serverless technologies. So in terms of understanding serverless, you really have to understand the individual serverless environments in which you're operating in. It's not fair to just say, hey, AWS works this way, so Google Cloud Functions must work the same way. Azure may work a different way. We have to analyze them separately. And some of the things that you want to consider when you're analyzing these different environments is you're going to obviously worry about all the application security concerns that I mentioned before and the role-based access control and the permissions, but you also want to make sure that the environment is secure. We're going to get into a little bit of detail regarding that right about now, a couple slides later. First and foremost, I want to talk about the different providers that are out there. I've already alluded to Amazon Web Services Lambda. This was kind of the first to market serverless technology, certainly the first one that gained major popularity. It's a runtime, it's a platform that allows you to run a variety of different runtimes for Node.js, Java, Python. In my experience, the vast majority of serverless functions are Node.js, followed by a good amount of Python, some Go. I've literally never seen in a production environment any of the other languages, but Amazon supports not only these languages, but also the ability to bring your own runtime, such as the ones that have already been contributed to the community, C++, Bash, PHP, and Rust. And basically, all you have to do to get started with the function, a Lambda, is to configure it to have the appropriate permissions and to define the resources that it has access to. The way that pricing in Lambda works is kind of interesting. They've combined a variety of different resource types into one pricing model. So you basically determine a power rating, and they measure this in gigabytes of memory. But alongside that, you also get network bandwidth and CPU power. So they group it all together. You can't configure those things independently, but in their research, it is not necessary to configure them independently. These functions operate with the CPU associated with the memory that you allocate. And you only pay for the consumption, but as mentioned before, it is not as simple as calculating the number of invocations. It also is important to understand how long are these functions running, what your power rating is, because the amount of time your function runs is more expensive based on the power rating, and also all of the other services that you talk to, because you're not going to use your serverless function to persist data. By definition, serverless functions are ephemeral. So if you need to persist data, you need to send that data to another service, such as DynamoDB, S3, or Elasticache. There's also a lot of great logging and auditing capabilities in CloudWatch and CloudTrail. It allows you to determine who's invoking what function, when, and you can get a lot of important information there regarding authorization, potential indicators of compromise, and much more. In terms of controlling access to your Lambda, the main thing that we recommend is ensuring that your functions can only be invoked through an API gateway if they're API functions. There are a lot of different ways that you can use functions. You can use it for a whole variety of different applications, such as processing files when they're uploaded to S3 or based on a schedule. But the majority of use cases that I've seen are related to powering an API without running a server. And if you're going to do that, you don't want to implement access control on each of those individual functions. That's a lot of work and is very error prone. So instead, use a centralized API gateway or an application load balancer or something that is going to consistently manage access control for you so that each function can assume the benefit of that protection. Make sure that you're using a custom role for your functions, because each function has different resources that it needs to access. And that's another security benefit of serverless. If you have a monolithic application, you have to grant it all of the IAM permissions that the sum of the application needs to use. If you want to say, oh, this part of the code uses this permission set and this part of the code uses this permission set, maybe you can get away with it using session policies, but it's very difficult, it's very complicated. So a lot of developers just say, okay, I'm gonna give this server all of the permissions that they need, every permission that they need for the entire application. Now, you can break up that functionality into small functions and give each function the exact permissions they need, which is a huge improvement in my opinion. And finally, you want to make sure that you have proper network security. So by default, AWS Lambda runs its functions in a VPC that is managed by AWS. If you want to have the same controls you'd have in your VPC for a monolithic application, you should look into running your function in a VPC network. This will get you the benefits of being able to use security groups, as well as create flow logs and analyze the traffic that's happening within that environment. And finally, to utilize VPC endpoint policies. And we talk a lot about that in Sec 510. If you'd like to learn more about that, feel free to ask me during the Q&A. So what does the default configuration look like for AWS Lambda? Well, the default configuration is there is no HTTP trigger. And this is a huge difference between Azure and GCP. Azure and GCP, when you deploy a serverless function, it automatically comes with an HTTP endpoint. And when I say HTTP endpoint, I don't mean that it's an insecure HTTP:// endpoint. It's using the HTTP protocol. For AWS, you can't connect to API gateway via HTTP. You have to use HTTPS. But what I'm saying here is you have neither of those two things by default with AWS. It does not automatically give you an endpoint. You have to create an API gateway to expose traffic to your function. And in addition to that, in terms of network security, the egress traffic from your function is basically wide open by design. It's able to do everything by default with the public internet. It's not accessible from the public internet. That really depends on your API gateway, but all the traffic coming from the function is allowed out unless you put it in a VPC and set up your security groups. So that's what this looks like, adding an API gateway to actually expose it to the world via an HTTP endpoint. We have it in a private subnet now, and that private subnet can have security groups for it that allow for us to prevent egress traffic from going out, which would be excellent. In addition to that, one of the most important things is to, again, ensure that your API gateway has proper role-based access control. And one of my favorite features of AWS API Gateway is their concept of custom authorizers. This allows you to run a function or run some other authorization check prior to running your Lambda completely independently. And as a result of running that function, you can determine what permissions you have to actually invoke the function in the first place. So this can be seen as a gateway for all of your individual functions. And understand that you can modify the timeout of your functions between 5 seconds and 5 minutes. I think that's the maximum that a function can run for. But for an API gateway, you have a hard limit of 30 seconds. If your API takes longer than 30 seconds, it will terminate, regardless of the timeout for your function. And the good news is there's very few applications that require an API to wait 30 seconds. You may want to consider a different entry point for your function if it's going to take 30 seconds to run an API, but just something you should be aware about. Now, how do we get set up with an API gateway and our functions? Well, you can do this with your normal infrastructure as code solutions. As folks know who know about me, I'm a huge fan of Terraform. But it's not the best for managing serverless technologies. There's another technology out there called Serverless Framework that allows you to very easily specify what code you want to run and how you want it to be executed. So in a handful of lines, you're able to deploy a function with the Serverless Framework. So if you want to experiment with serverless, I would definitely recommend this tool as a great starting point. In terms of putting it in a VPC, in serverless, it's quite simple as well. You define the VPC, you define the security groups, and you define the subnets. And that will help you be able to monitor your internal traffic as well as grant access to different VPC resources. So a couple of things you should be aware of regarding the serverless environment. As mentioned before, these functions run on actual servers. It's not magic how these work. The providers spin up a server, they run your code, and eventually they go away. That means that if you get access to a serverless function, you can read all of the files on the file system. Now, thankfully, there is not a SSH port open on your serverless runtimes. That would be ridiculous and completely unnecessary. You only use SSH for administrating a server, and that's the entire thing we're trying to get away from. But it is still possible to access the file system using a command injection vulnerability or a supply chain vulnerability. And Eric and I, the two authors of Sec 510, we actually created a tool that I referenced in the Slack channel called Serverless Prey that allows for you to deploy functions to the big three cloud providers, to AWS, Azure, and GCP. And it allows you to run commands on those individual function runtimes. And this helps you analyze what all is going on in there. So the next couple of slides are going to show the results of the commands we ran in Serverless Prey. So here we can see our source code is on the function. If we have any secrets in the source code, now we could access those secrets just like with a normal application running on a normal server. Furthermore, there are a variety of environment variables that are set on an individual function. The most important of which is when you define a role, an execution role for your function, it needs credentials to validate that it has the permissions that it needs in order to interact with other services. So how are those credentials provided? Well, in EC2 and ECS, you have what's called an instance metadata service. There's been a lot of documentation on IMDSs in the past year, and you'll understand why if you understand the main story associated with IMDS, the Capital One incident. But for serverless, you don't quite have that because it's kind of inefficient to make an API call to get your credentials. So as a result, they provide those credentials as environment variables instead. So if you have the ability to run ENV, you will see all this data, including these credentials that you could use to impersonate that function. There is also some level of persistence. If you write a file to the file system, it will exist for as long as the container running the function exists. Now, to Amazon's credit, which is something I will give them way over the other two providers that don't have this restriction, AWS Lambda only allows for you to write to the /temp directory because they recognize that there will be needs for functions to process files. And in order to process files, you oftentimes have to have access to the file system. So they only allow you to write to the temp directory, but nonetheless, I could persist malware to the temp directory. And potentially even more importantly, if your function is processing sensitive files and the function doesn't clean up after itself, it doesn't remove the files from the file system, potentially an attacker can access them on future invocations as long as the function is running. And not only will the function continue to run due to activity, which the attacker can control, but some developers actually run plugins that keep their environments warm on purpose. So serverless is not as serverless as we may think, especially when developers are doing things like that in order to get the benefit of not going through a cold start. Gonna go through a couple more slides quite quickly. Lambda also supports the ability to create layers, which allows you to import a bunch of code on top of your actual function code. And this can be very useful for not only managing dependencies, but it is also useful for using third-party security solutions. Now, it's really important to ensure that the layers that you're using are secure. And we know about the supply chain vulnerabilities out there where third-party dependencies can be compromised. So you should be skeptical of the layers that you consume. You should perform internal package management if possible to ensure that the packages that you use are thoroughly vetted, or you can use security solutions like PureSec Functions Shield or Twistlock Defender to gain yourself some runtime security of your functions, to block invocations that are not allowed, that are maybe made by a third-party dependency. And PureSec Function Shield is one of those technologies. It basically allows you to restrict what your function can do at the code level. This slide will be recorded, so you can look into more details shortly. We're coming up on time. Here's the source code to use Function Shield. I think that this is a powerful technology, but at the same time, I'm fairly skeptical of asking our developers to write more access management or configuration code. They're already writing such complicated things, such as IAM policy. So I think the runtime solution of the future will be able to determine what is normal behavior and what is not normal behavior automatically using machine learning, AI, and other buzzwords. But having our developers do this manually, I think, is quite hard to prescribe to them. So in these last couple of slides, there are some examples of configurations of functions that you should think about. Think about the variety of things on this slide. You have to think about a variety of things to understand the security of a function. I'll just highlight them right now. The code that you're using needs to be scanned and audited. We need to make sure that the runtime that we're using is secure. In this case, we're using a deprecated runtime. We need to make sure that we have proper authorization, proper permissions, and proper network settings. And in addition to that, we need to make sure that the permissions that were granted are not ***, just like the previous talk mentioned. So with that, here's another function that has an issue with regards to logging data that is not to be logged. So I'm going to conclude this by just saying we have a lot of resources here at SANS in the SANS Cloud Security Curriculum. If you go to sans.org/cloud security, we have a lot of resources, not only on the cloud generally, but also things specific to serverless. We have a brand new poster that came out that has a lot of great information about the differences between the three cloud providers and different considerations you'll need to make from a security perspective. And all of this is free. So if you are able to take a course like Sec 510 and Sec 540, I'd highly recommend it. But to get started, take a look at all these free resources that SANS has produced. And I'm really proud that SANS has done so much to increase their free offerings during the pandemic so folks can remain productive and well-trained while budgets and training and travel may not be available to them. So with that, thank you so much. I'll kick it back to Frank if he has any questions from the audience.
Brandon, that was awesome. Great presentation as always. A lot of amazing information there. Just given time, we do have a few questions that have been asked, and we're going to ask you to jump on the Slack channel to respond to those questions. But we're going to go ahead and everybody give Brandon a virtual round of applause. Thank you very much for the great information, and we will see you on Slack.
Most certainly. Take care. Thank you.
All right, now I'm going to go ahead and we're going to segue now to the next two speakers here. We've got Ross Warren, Solutions Architect at AWS, and Vinay Sukumar, who is a category leader at AWS as well. So Ross, Vinay, I'm going to turn it over to you guys.
Thank you very much, Frank. Can everybody hear me okay?
You're coming through fine, Ross.
Sweet. Thank you, Vinay. All right. So Vinay and I are going to talk to you today, coming a little bit out of the weeds from what Brandon was talking about. There probably will be no code in any of these slides, but we really want to talk to you about maturing your IR operation, your IR functions. We're going to walk through a little bit of what a cloud adoption framework means, hit at some security epics, and then we're going to progress through a couple stages of what an IR maturity model. How do we get there? And Vinay is going to finish up with AWS services and AWS Marketplace functions that can help solve some of these challenges that you're going to see. Whether you're on AWS, whether you're coming, building your organization on any cloud, you're going to have to go through a cloud adoption framework. This happens to be labeled AWS. It's not necessarily specific to AWS. But I want to highlight, right? You need to, the first thing there, implement a strong identity foundation. And so in AWS, that is IAM, really needs to be the first thing you need to think about. What are my users doing? How are they authenticating? What am I allowing them to do? A bunch of these other things you're going to see as we go down through the rest of these, but they all are talking about maturing that IR organization. We want logging. We need security at all layers. We want to talk about automation, protecting our infrastructure, protecting our data, and then not last, but incident response, preparing for security events before they happen, right? When I do talks, I really emphasize the fact that you need to have your security tooling, logging, monitoring on before something happens, whether it's malicious or not. It's really, really hard to go back in time and find those logs that you just actually didn't ever capture. When you're talking to or when you're starting to engage AWS, a couple different ways, but I want to highlight these security epics. These are a program in AWS Professional Services for customers who may be greenfield, who are just starting out, or even not sure what to do on the cloud. And if you see, they really, really match up with what I was talking about with that cloud adoption framework. We need identity and access management. Professional services is going to walk you through those things. I'm not saying you need professional services to do those things, but if you're distracted with lots of other business challenges, talking to professional services with these different epics, getting your logging and monitoring right, finding out where all your logs are, getting them in one place. What do my VPCs look like? What do my security groups look like? Do I need encryption? What types of encryption do I need? Where do I need it? And then there is an epic to help you work through what does incident response look like in your organization. Once you've got those sort of yellow or gold foundational things, you can then, depending on your op tempo, depending on your organization, you can start looking at, hey, I've got big data. I want to now augment, my discussions with professional services. As I said, you don't necessarily need to go use professional services, but as a company, know that they're out there and they can be part of a discussion with an SA, with other folks as you're spinning up. So Vinay and I are going to kind of bop back and forth between strategy and execution. And so I'm going to turn over to Vinay for right now.
Thanks, Ross. So I know you mentioned incident response a couple of times, right? But before even we get to there, we need to talk about threat detection. And then what are the controls that you have in place from a preventative perspective? So when Ross and I were putting the content together and thinking about, based on our experience with the customers and what we've seen in practice, we said broadly, we can classify the maturity model into 3 stages, right? So basic, advanced, and then mature. And then the reason why you're going from basic to advanced directly is because basic doesn't mean you're getting started from ground zero. It just, by the time you're thinking about threat detection and response, you already have or should have done a bunch of work, right? From a security perspective, from an infrastructure perspective. So this is to identify what are those key things, and then and also be able to tell where you are in this journey so that you can put a pin on it and then draw a vision as to how you can get there. So from a basic strategy perspective, first thing I'd recommend is to look at a framework, right? So framework basically helps you marry industry standards and best practices and tries to put it in a way that it's a common language across the different teams, and you can map goals to it, and then you can see where exactly you are today and how to progress from there. So NIST framework is probably one of the more popular ones, where we talk about the identify protocols. We talk about protective or detective or response and recover protocols. So these are things that you should think about in terms of when you're setting up a practice and understanding where you are in the maturity life cycle. And the other thing important here is to make sure you have security representation in the cloud services selection process, right? Ideally, representation in every decision making, but especially around cloud services selection process, because where oftentimes business is looking to run and get things done, security comes as an afterthought, and that is changing definitely in the industry today. But we need to make sure that we get in front of that by having the right people in the process. Where possible, drive selection from a FedRAMP approved list. And what this means, the FedRAMP is just an example, right? But what it means is you have a reputed agency, and these vendors have gone through rigorous selection and criteria process, where they've gone through an evaluation criteria and come out as successful and being approved or authorized to deploy in a federal agency. So you can piggyback on some of the work that's already being done while selecting your solutions. And make sure you have security processes that can scale with the organization. So oftentimes we focus a lot on technology and the platforms, whether it can scale as you grow, but also it's important is whether you have the processes and the people that that can scale along with it. So today with SaaS offerings and in the cloud, you can easily scale from having a small footprint or a small organization that you're covering to a very large enterprise. And the same platform can scale, but then you also need to make sure you have the people and process. So when you're building your vision on how you want to grow this practice, make sure you cover for those as well. And start with cloud native services. And you will see, as we go along with the presentation, examples of how AWS native services comes in and what are the areas that they can help you. But these could also be third-party solutions that are born on the cloud that fits well in your story, depending upon where you are in your cloud journey. And by virtue of being hosted in AWS, they also inherit a lot of the best practices and standards that we put in place and support our partners with. And focus in this stage, you'll focus on preventative and detective controls. That means, think about whether you have identity and access management set up, OS hardening, patch management. And from a logging and monitoring perspective, make sure you have all the relevant data flowing into your systems. And one thing I'll highlight here, it's not just about getting the data in once. Put in a monitoring to make sure anytime the data stops flowing, you're alerted, right? You don't want to know that the data stopped flowing 8 hours down the line or when an incident happens. So all of a sudden, a critical server is no longer being seen and it's gone silent. You need to know that information. Over to you, Ross.
Thanks, Vinay. So execution. Vinay talked a lot about strategy, what you need to think of sort of in the big picture. I'm going to talk about execution. There's not immediate, top 10 steps you need to do. Everybody's journey is different here. And as I said, we need to have some things in place so that you can figure out what happened. Where do you begin? And I'm going to have a slide in a little bit to talk about where you are actually beginning. If you've already got a security operations center, you've got an IT operations center, maybe on-prem or in other places, take a look at what your last month's tickets are. What did you get? Sit down, take a breather, walk away from the computer a little bit, and just what can we learn from what we did? And since we're in the cloud, since we talk about Terraform, we talk about CloudFormation and infrastructure as a code, what can we actually automate? Take an audit of what you're seeing in your tickets, automate one thing. It's going to be addictive. It's going to be, leave that ticket open until you've got enough enrichment, until you've got enough tagging, until you've got enough legal buy-in to what you're actually going to automate. It's going to be addictive. You're going to want to do this over and over again, and you're going to want to hire and train people who like to do that curious person who's not just going to take yes or no for an answer. You're going to continue to sort of evolve that process and build a machine. That machine is people, processes, and technology that's going to continue to solve those problems, solve little problems that make a bigger impact over time, right? You may be doing some of this now with regular IT processes, but think about doing it in incident response in the cloud. So you're leveraging what you already do well with your IT processes, internal building systems, building old images to deploy on desktops, those things, and you're going to grow incrementally. What's great about the cloud is we can actually build things cheaply, quickly, build a flight simulator, build something that your IR folks can actually play with, ingest errors, ingest things that they're going to go look for. There's plenty of guard duty tester things out there, or if you want some other scripts, we can work on what's going on, but build something that they can test and play and give them time to do it. Hey, you've got an hour today to go learn X. You've got an hour today to go do this. Is a great way to start maturing your organization. The first bullet says automate yourself out of a job. I don't necessarily mean that we all become robots, but you want to, as I hinted at, don't close that trouble ticket until you've got fix it. Make sure that you're no longer vulnerable, but put it in a state where I'm researching, I'm figuring out, I'm trying to understand if I can actually automate this. It may not be tomorrow. It may take a little bit of time to do that, but you've got tools, at your fingertips, Inspector, CloudWatch, config rules, things that can do that for you. Those then should naturally flow into, I'm writing a run book. Here's an alert. Here's a finding. Here's what I go do with that. Who am I escalating to? Do I actually automate this? Who am I notifying at 3 a.m. versus 8 a.m.? Who's on the weekends? All those people, processes, and technology need to be part of that run book. And last in the slide, make sure you control public access. We all know what happens if you get on the S3 public bucket bad list, but make sure that is part of even your basic steps as you're trying to mature your IR organization. That just, if you fix it, it becomes it is not part of the noise, and I know that I'm secure there. Lots of times I talk to my customer, Ross, there's so many services. Where do I start? And if you remember some of those words from that cloud adoption framework that I put up in the first slide, I've kind of mapped them here for us. I basically tell customers, you're starting on your cloud journey. You've got to get your IAM strong identity foundation right first, or have a way to get there. CloudTrail, I need to enable traceability. I need to start turning on logs so that I know what API calls are happening. I need to turn on CloudWatch so I know what my services are telling me. If I've got Guard Duty or Security Hub or Macie turned on, I know what findings are actually going into CloudWatch. So I'm preparing for my security events. And config is really starting to bubble up into a really more important service. If you haven't looked at it, I think it's one of those foundational services that you need to turn on, not just enabling compliance monitoring, but checking your stats, checking where configurations drift. It's a really good thing. So this is not necessarily a straight line journey, but these are things you need to think about. This isn't even IR. This is things you need to think about to make that base so that I can move from a basic cloud practice to a more advanced practice.
Yeah, I'll jump in, Ross. I mean, a good way to summarize the basic stage is if you're going through a security audit, there's a bunch of questions being thrown at you and information being asked, you should be able to go to a quick pane and then tell what is happening in your environment, or what assets you have and where it is and what practices in place. So that's table stakes at this point. Now from there, moving on to the advanced strategy, what you would look at is, now I've done the preventative measures, I know where things are, and I was focused more on detective controls. So this is where I'm going from being reactive or trying to mature things to a point where I'm going beyond signature-based alerting, signature-based rules and processes, right? So you will mature your detective controls and capabilities to a point where you're using AI ML. You're able to look at anomaly detection. You're able to understand, user behavior analysis and understand, where the users are and what they're doing in your environment, and also build a response automation, right? So this is where solutions like a SOAR platform comes into play. SOAR as in security orchestration and automation and response platforms, and they come with their own native set of playbooks and runbooks. But it takes time when you start on this journey to build custom responses specific to your organization, your requirements, and you can extend these capabilities with third-party solutions. And in this stage, you will be focusing on the highest value data that covers not only the network and system monitoring, but also cloud environment monitoring. So this is where the control plane comes into play. If you're a SaaS application, if you're a SaaS vendor, then are you SOC 2.0 compliant? What are the requirements for that? Do I have visibility into all of that information? It's not a one-time report, but how do I keep tabs on all of those? Have a tiered support structure that is in place, right? So this is where you take the tooling and the technology and the people that you have, but now you have to put a process in place, and you want to focus on automating as much tier 1 work and effort as possible, where you take those same resources and the time that you have and implement into focusing on tier 2 and tier 3 in terms of investigation. This should be an effective feedback loop that goes back into your detection capabilities, but also inform your business on what is happening. Establish an escalation path to identify business and security owners. So what that means is, it's not only about resolution from an IT perspective, from a technical perspective. You need to start engaging stakeholders in different silos within your own organization so you can articulate the impact of an incident, impact of a particular event in terms of business. It could be from a reputation perspective, it could be from a dollar value or a customer experience perspective. So having these business partners identified as part of your process, you're quickly able to bring to their attention as to what is happening and why they should pay attention. And they'll be your champions going forward. And take advantage of the automation tools that can serve as a force multiplier and assist the security teams immensely. And this is where you actually start building more into risk, marrying the security operations and mapping those to your risk assessment and the risk posture for your organization. But some of the things that you can start with from an execution perspective is what we have here.
Sorry for that quick jump. So as I mentioned in the basic stage, right? I said, take a deep breath, start having meetings about, what you can think about automating. What are my lessons learned? In the advanced stage, you need to continue to do that. That needs to be a regular process, not just shift change in the SOC, but IR scenario planning and prioritization sessions. You're helping to reduce the noise. You're helping to determine what more can be automated, what network changes need to be made. Not everything that we find in IR is a malicious incident. Sometimes there's just changes that we need to be made. And what are we prioritizing? We're going to get lots and lots of alerts. And so you are doling them out, or you're prioritizing who's fixing, investigating, enriching, tagging things things that help with my real-time metrics, that help with my automation, right? When you're at this advanced stage, you're starting to really dive deeper into automation. You may have 2 or 3 things that are working really well now, but now I'm starting to challenge myself in the harder things. I need to really gather a lot of information before this automation takes place. Maybe I'm developing my own. I see what somebody else has done through some blog post. I'm really starting to develop my own automation. You're starting to, not everything is an immediate fix right now. I'm starting to develop thresholds. I maybe now have a tier 1, tier 2, and 3 sort of SOC organization where the first stuff, the easy stuff, is being hit by those tier 1 folks, maybe some of my junior folks, and they bubble up to 2 tier and 2, 3 as we're going down. And as I kind of hinted at, right, security escalations for access. When someone's asking for access, do we give it to them right away? Do we know what their reasons are? We need to develop a process for that so that when the exception happens, I know that it is outside the scope and I open a ticket and I can securely see what is going on there. Sometimes when you're in the middle of an incident, you don't necessarily want to put everything in the public or in easily accessible. So you need to start thinking about secure communications for your incidents. Is it a separate Slack channel that's outside? Is it some other communication mechanism so that if you are infiltrated, you are able to completely talk about it without the bad guys knowing about it? You should be, by now, at the advanced stage, collecting CloudTrail for your entire AWS organization. And as you get more and more advanced there, you really should know how to query CloudTrail. Dump it to Athena. Start looking at, there's some public GitHub repos out there for, really cool queries for CloudTrail. Start building your own. Start taking that and building what is really meaningful to your organization and understand what is in CloudTrail. And as we advance, you're going to start getting more and more sources of data. As we've mentioned, Macie, GuardDuty, CloudTrail, CloudWatch logs, VPC flow logs, even logs from maybe some of your servers or your instances from the host level. What do you do with this? We've already kind of talked about that in the basic step. And as we're moving more and more advanced, this drives to automation. This drives to escalations. This drives to notifications. This drives to opening tickets. That big Lambda function really is the art of the possible. What do you need to do with that incident? Whether it's automated, whether it's one of those custom actions inside Security Hub that inform a Slack channel that isn't normally part of your security workflow. Really taking all of these logs and wrangling them together, making an informed decision to write that Lambda function or to modify someone else's Lambda function to fit what your business needs are. So the slide earlier was really about basic core security services or core services at AWS that you should have enabled. Now we're more in advanced. We should have GuardDuty on. One of Steve Schmidt's sort of top 10 things that you should be enabling is GuardDuty, but not just turning it on. You want to start operationalizing what you have there, integrating it with your IR processes. And that's going to be an iterative. So I got that little loop there. You're going to continue to go back and refine those processes. And as you mature more, maybe security comes into play. Maybe you already had Security Hub on, and then you need GuardDuty on. So it's not necessarily, as I said, a straight timeline here. Security Hub is really a great place for you to start aggregating security standard findings, GuardDuty findings, other processes or other services from AWS, and then where do I automate response actions? Take a look at GuardDuty. There's a couple good blog posts out there about automating response actions. And then as you get to that sort of hunting level, which we'll talk about more in mature, detective really comes into play, really doing deeper dive security investigations with your organization.
Thanks, Ross. So, I mean, just one point on the previous slide. I didn't see AWS Detective or called out as a separate service there, but I think that is one of the recently launched services that I'm really interested about. Where it is actually gathering the data for you from an investigation perspective, right? So for IR, and it's ready, but minimal impact to your environment. So definitely turn detective on as part of your operations. At the mature stage, so this is where you have all your security controls covered, and you have as much automation as possible. And we pivot our focus from being reactive to actually being proactive, right? So you need to make sure you have forensics capabilities. So in case of an incident, so I mean, we no longer talk in terms of if an incident happens, it's a matter of when. So in case an event happens, what are the things that you can do to go and learn how it happened? I always say the bad actor only wins if they're able to take the data out that they came after, right? So even if there's a breach, as long as the data does not leave your environment or whatever they came for doesn't happen, you still are under control. You should be able to quickly switch on or go to a forensics tool and be able to see what happened and isolate the indicator of compromise and learn from that. And then build a threat hunting practice, right? This is a separate team. It's not your SOC tier 2 analyst trying to understand what's going on. It's a separate team focused and enabled with modern tool sets to go after vast amounts of data, looking for those needle in the haystack like scenarios, and learning and understanding and putting probably working with honeypots and understanding who's coming there, who's biting that, and building practices in place to protect you. And that actually becomes a main feedback loop from an intel perspective into your threat detection and response practice. Have periodic proactive risk assessment. And in this case, what happens is, this is not risk assessment purely from an IT perspective. Now, this is risk assessment from a business perspective. I talked about the stakeholders from different areas and being able to articulate business impact, and that's what this comes down to. And have security representation in every silo in your organization. A mature practice is where, when any decision is made in the business from an application and organization perspective, there is a security perspective that is included as part of the decision-making process. And your response plan should also include other stakeholders like IT, business, legal, your PR teams. So there is impact to the business, and you're able to capture that by involving these people as part of your response playbook. And align with your industry peers and to collaborate on threats and insights. This is very important. It's probably the most obvious thing, but it's not front and center for a lot of customers. Identify who are your peers, what industry vertical you're in, and what are the common threat actors you're seeing. And share content, right? You can scrub information, but you can share rules that you've built that helped you in certain scenarios. And selfishly speaking, for each of you from an organization perspective, the more you're able to share and develop this, it's going to come back to you, and the more robust your security posture is going to be. So what are some of the things we can do from an execution side, Ross?
Actually, it's not on my slide, but I really like that last point. You talked about sharing, right? Not just sharing internally, but as you get to a more mature execution, you should be at a point where you're able to actually share maybe your IOCs in an environment, and shows that you are a leader in this IR space, in a leader in doing these things. So sharing internally is also important, right? As you are more mature, you're going to have a lot more people on your team who are going to have that experiences of what is normal in my network. This is how we do things. And so remember, I talked about people, processes, and technology. So really mentoring your junior team members. They're the tier 1 folks who are really going through the lots of the noise and trying to figure out what's real and what's not real, but have a clear hiring process and a development process, and maybe a SANS class for them as a development program. Vinay also mentioned a hunting program. Maybe by the time you get to mature, you're already sort of in this part, but if you're not, it's good to start thinking about threat hunting. Start with 20% of your day, start with 20% of your week, and start just giving your folks time to do threat hunting, whether it's searching for an IP address, a role, or an instance, or something else. Give them that time. SOC folks are curious folks. If you've hired the right people and they want to go do that threat hunting, and that threat hunting becomes part of the loop, informing that proactive detection back. And as you mature, get that dedicated hunt team. By now, you should have also started to think about automated forensics. How do I automatically pull disks? How do I automatically get memory dumps? Where am I putting full packet capture if I have the ability to store and look at those? And also, DNS is very, very chatty, very, very lots of logs coming through there, but make sure you are monitoring your DNS too. Lots of good things coming out of that in this mature life cycle here. So Vinay, how do we get there?
Yeah. So a good question, and this is the important part, right? So it's great to identify the different stages and where you need to be, but there's always constraints as a business, as an organization, and the first and foremost thing that I always hear about is cost. Where do I start in? And anytime I'm looking to manage terabytes worth of data and do analysis, there's costs associated with it. How do I justify that? I'd always say start with native services. A clear example is, Ross mentioned about looking at DNS logs, and looking at DNS logs and being able to capture them and understand that maybe you can optimize some of those functions with an open source or an open source solution with an enterprise support, or with a solution that is relatively cheaper, right? You don't need to go for the Cadillac right away. But then what you need to do is, where can I start? What are the ones that are core to my deliverables? So identify what are your success criteria, and then build what are those data points, what are those assets that you need to monitor and track to deliver success for those, and then build a strategy around the remaining where you can mix and match. There is no one silver bullet that is going to solve everything for you, and it's not going to be cheap if it did. So what you need to do is start with, my recommendation is start with native services. We talked about GuardDuty, Security Hub, Detective. Work with your AWS SA and team, reach out and say, hey, here's what I'm looking to do. And what are some of the things that you've seen in the field? When we started putting this talk together, ideally we wanted to talk about examples and go through how it happened. But in 30 minutes, you can only do so much. So reach out to us and let's have a session where we can talk about what is it that exactly you want to do, identify your goals, and then how we can align either with native services or using our partners that we can help you with. Build a business justification, right? So this is where your stakeholders, and you need to show the impact for other teams. You can't just say security needs this, I need this to happen because security wants so. Why it means to them and how you're going to help them by accepting or adopting what you're saying. So map benefits to business outcomes. And finally, managed service partners and consulting partners are a key component of this practice, simply because there just isn't enough people with skills to go around. This has been an issue for over a decade, and I don't think it's going away anytime soon. So you can start, these consulting partners can help you hit the road running right away. And while you build your practice, and they could be a handover, or you can work together going forward. So definitely include them as part of your consideration. But work with your AWS team and the account team, the SAs, and the marketplace teams to help you identify some of these solutions and build a strategy. If you go to the next slide, we actually put together a list of all our services. Some of these services are repeating depending upon whether they also play a role in the identify stage as well as detect stage. But the idea here is, this is a mind map of what are those services and capabilities and tool sets you need to think of as part of your organization's security capabilities and how you want to mature that. And then add on top of this, if you go to the next slide, you will see a number of third-party solutions and vendors that's available. Security is it is one of our top categories within Marketplace where customers come. And where this becomes really influential is now when you start your journey and you identify a need that I need a solution X, Y, and Z, you can actually go and learn about the solution. You can read case studies, all of these in a single place. You can try that solution, and then you can start using it in a pay-as-you-go model. And once you're convinced, you can continue, or you can reach out to AWS to help you get a longer negotiated contract with Marketplace. You can find the solution, you can buy the solution as you choose to, and they can deploy either as a SaaS, ARMI, CloudFormation template, containers, and any of those form factors of your choice. So take advantage of those as well, and consider AWS and Marketplace as your resources to help you mature on this journey. Over to you, Ross.
So on the behalf of Vinay and I'd like to thank you very much for having us talk a little bit about more maturing your IR program. I promise there was no code in the presentation. And there were a lot of high-level concepts that I talk about with customers all the time, and we eventually get into the weeds. I want to leave you with this one quote from Merit Bear. If you've heard her talk, great to go listen to her. She now has a new role in the office of the CISO for AWS security, but she's been talking about building a machine for actionable security for quite a while now, and I've really taken that to heart. And hopefully you saw some of that come through as in the automation, as far as leaving that ticket open until you've actually solved the process of how to close it, whether automatically with a run book, and making sure that people, processes, and technology are part of your discussion. We're in virtual reInvent time, and just wanted to tell you, give a shout out to Freddie K, because I can't pronounce his last name. He's actually doing a talk about a little bit more in detail about building your cloud incident response program on January 13th. So if you haven't signed up, go take a look. I'll be listening to Freddie's talk also. So thank you very much, everyone.
Thank you, everyone.
Hey, Ross, Vinay, great presentation, a lot of great information. We do have a number of questions that have come up, and at this point, we're right at time here, so we're going to go ahead and take a 10-minute break. We'll transfer those questions over to Slack if you guys want to follow up with some additional questions. So everybody give them a virtual round of applause. We are going to resume here with our next presentation in 10 minutes, everyone. See you then. Hey, welcome back, everybody. We're going to go ahead and introduce our next speaker, who is Sean McCullough. He is the author of our brand new SEC 541 Cloud Security Monitoring class, and also an instructor of the SEC 545 Cloud Security Architecture and Operations class. So with that, Sean, I'm gonna hand it over to you to get going here on threat hunting in AWS.
Thank you so much, Frank. I appreciate it. I'm excited to be here. Actually, some great talks. That last one, I love getting these roadmaps of, this is how you go towards maturity. I at one point I was running an IT infrastructure group, and I brought in these giant charts of these. This is the ITIL framework we should be going to, and everyone's like, oh. But it gives you this great roadmap and say, all right, I see where we need to go to. What are the steps we got to get there? So I loved it. I learned a lot from that. Thank you. So I wanted to talk about threat hunting in AWS. Trying to take a look at specifically what are the kinds of attacks that might be different in a cloud environment than maybe attacks we would see in our on-prem environment, and really to look at some of the data creation services that AWS has, which have been mentioned, in some previous talks. So they're not new to you, but this is the places you go to extract log data, and I'm going to have to do something with that log data. And threat hunting is really a lot of that log data. So that is today's talk. So first of all, we got to do what is threat hunting. So let me make sure I can change slides here. There we go. Okay. So of course, what is threat hunting? We got to kind of distinguish it. Threat hunting, official definition would be proactive evaluation of the infrastructure. And that's really kind of like going out and figuring out what are attacks that might be happening in my environment that I can't readily see through my automated security services. So if I've got some malware detection system running on my host, and it says, oh, someone has downloaded this piece of malware and I've deleted it. Awesome. That's great stuff to track. I don't really consider that as much threat hunting because we've automated that. So threat hunting is more of proactively figuring out, hey, what are we vulnerable to? What are the kinds of attacks that I should be looking at? Can I detect that it's happening? And then going out and figuring out if that is happening. It's a lot of spending your time in logs, and that's kind of the good and the bad of threat hunting. I've talked to organizations where they'll have a couple people that's like their threat hunting team, and they're just given like a ton of logs, right? And it's just there's just a mount of it. And what do I do with these kind of logs? The good thing is that in AWS and other cloud providers, there's a lot of data that can be extracted from the environment, and it can probably be extracted in easier ways than maybe you're on-prem, where you have like 6 or 7 different kinds of services and software and hardware that's running and different ways of gathering data from it. In AWS, if you're living inside the environment, you have an easy API access to all your data. It's just kind of figuring out what is the data I need to grab first and how to make use of it. So a lot of logs that you might be dealing with. And so I want to talk a little bit about what is the threat and what are some logs that you might use to go and look at that threat. First part of threat hunting is figuring out in that proactive evaluation, I got to know what I'm looking for. And it's got to be it is a threat driven kind of mindset. So you can have folks do auditing that are compliance driven, and that's great. And have to do it for some organizations, but it's great to do that. Threat driven is more like, hey, what could the bad person be doing in my environment? What could the attacker be doing? What does it look like? Am I vulnerable to it? How vulnerable to it am I to it? It's really kind of taking on the mindset of this is what the attack may look like. And so in order to do that, we have to have some information about what are the threats out there. You probably have a threat feed that has APIs, domains, and hashes, and that's great. And those are great things to make use of. Atomic indicators are like that are easy to detect relatively. Nothing's really easy, but it's easier to detect with those services. And you kind of can say, all right, this is bad. I'm blocking it. That's great. When we start getting into threat hunting, we're starting to look more at behaviors, or this is something that is normally done, but an attacker can make use of it. So what does that look like? If it's something that I can normally do, what can the attacker do with it? And so we got to start looking at all these threats out there. It's a lot of digging logs. So we have to figure out what is the nature of the threat, how is the attacker going to use it, by whom? Maybe not so much is the attacker, I don't know, Fluffy Bunny or APT, whatever. That may not be as interesting, but if you got to know, hey, I'm in the, I don't know, healthcare industry, what are the kinds of attacks that are being seen in the healthcare industry? All right. I'm in the financial businesses, or I'm a mom and pop shop, you know, and your threats might be a little different. And so you can kind of focus on the threats that are more important to your organization. You also want to look at what the vulnerability itself is. You know, if there's a threat against my web servers, all right, let's spend some time looking at our web servers. What would the threat look like? Do I have the ability to extract the data to tell me the attack is happening? How do I get the data if I don't have it? And then I really believe that in threat hunting, the threat hunter should not just be looking at logs, seeing something weird, telling the SOC. And I've seen organizations where that's happening, and there's only so limited success from those threat hunters. What we really want the threat hunters to be able to do is understand this is the threat, this is how it works, and I can easily detect it, or it's difficult for me to detect it. And maybe it's really easy for the attack to be perpetrated. I've got information I can be feeding to my architecture team to say, hey, look, if you gave me the logs this way, I can detect these threats a lot better. Or if you install this service, we would block or mitigate or detour these attacks. And so the threat hunters, using this cyber threat intelligence information, can really drive a lot of discussion about how to fix the infrastructure. All right, so let me show you just a couple places that I like to use as examples for threat intel. This is beyond the IPs, domains, and hashes, right? So this is kind of like the behaviors. The first one I always go to is MITRE ATT&CK. That's probably just because I've been using it since its inception. I love MITRE ATT&CK. I love MITRE ATT&CK because it gives me a way of categorizing threats, difficult threats, that I can have a conversation with my other teams. So I can say, hey, look, go and take a look at this attack technique, give it a number, T1105, whatever it is, and they can go and look at it and go, okay, we're on the same page. Whereas before, it was kind of like, let me give you a big description of what I'm interested in, and then people have to kind of figure it out. I'm going to actually test the pen, if you don't mind. I should have told you ahead of time I was going to do this, but I'm going to make sure the pen works on this. So let me show you how the MITRE ATT&CK works, just from my the way I kind of visualize it. This top row right here is the tactics, or how I would describe it is the intention of the threat actor. So the threat actor wants initial access, or they want persistence or credential access or discovery. And then down the list in the columns, or down the row in the columns, is specific techniques. And you can click on those and you can get a detailed description of how would they do that. So one of these is cloud service dashboard or cloud service discovery. So you can click into that and you can see details of what is the attack and how does it work. So I do like MITRE ATT&CK. It's growing. I'm showing you their matrix specifically for cloud. They have them for just specifically AWS and GCP, Azure, and then of course, Mac, Linux, Enterprise. This is a great place. If you come up with new techniques or you just see them, you could submit requests for adding to their documentation. So it's great. I love it. All right. But that's not the only thing. In our cloud environments, you're probably got a lot of web servers. Maybe it's web servers like humans are going to use inside of a browser to go browse something, or you might be moving a lot of your infrastructure from monolithic applications into microservices, which could be a lot of web servers. So OWASP is an organization that comes out with this top 10 list of web techniques that you should be looking at. Web threat techniques or web actor techniques. These are the things the attacker can use against a web server, and they've prioritized the list. But each one of these you click into, there's a wealth of information of what is the attack technique? How would you mitigate it? Here are specific examples of it happening in the wild. And here's how you can test in your own environment. So, you know, if there's an attack against a web server, they'll have ways to describe the attacks. Since a lot of our infrastructure in the cloud, especially a lot of our vulnerable infrastructure can be web applications, I always say this is a great second one to go take a look at. The third one is the CIS critical controls. It's probably not really cyber threat intel because it's not describing an attack. It's on the control side of things. But I really think it's a fantastic way of figuring out, okay, is my environment locked down? If I have these controls in place, am I able to detect things easily or maybe mitigate things? The other great thing is that in Amazon, there's a lot of services like Config and Security Hub that are mapping their results to the CIS critical control. So I'm a big fan of CIS critical controls. I'm a big fan of their benchmarks for EC2s and AMIs, those kind of things. So definitely another place to go and look and learn and understand what are the threats and the protections against them. So big fan of those. All right. So what I'm going to do is take a look at individual attacks, you know, and it's just a sampling of them. And one of the tools that you could use in AWS to go and detect those attacks. And now for every one of these things, there's a long conversation of how do you analyze it, how do you detect it, all those kind of things. But I want to really kind of highlight this is where that data lives. So the first attack is from the MITRE attack techniques. I didn't mention it before. The word attack is adversary tactics, techniques, and common knowledge. So it's an acronym that makes up a word, which MITRE does that a lot. They spend a lot of time making those acronyms into words. But there's one particular MITRE attack technique in the cloud environment or in the cloud matrix that's called cloud service discovery. This is the idea that, hey, if someone were to gain access to your environment, let's say they're sitting on one of your EC2s, an attacker has gained access to that EC2 because of a misconfiguration or the web server has a vulnerability, whatever it is, it's going to happen. Likely. So it's hard to say from security teams that, hey, this is going to happen to you, but it will happen to you. Once they gain access to their environment or they get your keys or they get some kind of security credentials, the first thing you're probably going to do is start figuring out what's running in the environment. What do I have access to? And so they'll start looking at things like, what are the S3 buckets? What are the EC2s that are running? What are the IAM roles and the users and like all of this stuff. And this is all about discovering the service itself. It's really simple. As a developer, you're probably doing this all the time, or if a security team, you might be running these commands, but the attacker is going to be running the same commands too. So AWS S3LS, I would give me a list of all my S3 buckets. That would be as an attacker, that's the first thing I would do. All of those interactions are interacting with Amazon's control backplane, which means they're API calls, and those API calls are being tracked in AWS CloudTrail. The AWS CloudTrail service allows you by default to retrieve most API calls. Now, the last time I looked, these are kind of a list of some of the API calls that are not fully provided in the CloudTrail. That actually changes quite often, so there might be a little behind on this. But this is August, I think, is when I went and grabbed this. But things like Trusted Advisor, maybe Workspaces, Artifacts, you may not get all the API calls. But for the majority of your environment, anything that you're doing about manipulating, changing, creating, or listing EC2s, S3 buckets, it's all going to be tracked in CloudTrail. CloudTrail by default stores that data for 90 days, but you can specify, hey, I want specific types of logs to be stored for longer. You can send them to an S3 bucket, or you can send them to CloudWatch, which I'll show you in a minute. But this API information is really describing when the query happened, by whom, was it successful, who returned it, but not the data itself. You're not actually getting the list of the S3 buckets in this call, but you are seeing that the call's been made. Data is being stored in JSON format, so it's pretty easy for an application to go and extract that information and analyze it and do something with it. All right. So the CloudTrail screen is really going to give you some good information in the GUI. Like if you go and click on CloudTrail and you're taking a look at it, it's going to give you some good information about when it happened, what was the event name, so this case listing the buckets, the source IP address that it happened. So if it's happening outside of your AWS environment, that'd be one thing. If it's happening inside of your AWS environment, another one. I also like to look at things like the error code, access denied. If you are working in an environment that you have high levels of automation, you have infrastructures, code, and all these really great fancy terms, your coding systems, assuming that they're working as expected, they're not usually going to go and query S3 buckets. And they're certainly not going to query S3 buckets on a system that's not denied. Like it's kind of been built so you don't do that. And so, but if I were an attacker and I were to gain access to a web server and I were to start to look around, I might get some access denies because my IAM roles are not set up properly. So you can start kind of looking at this CloudTrail. You can say, hey, there's an attempted query. It failed, maybe it succeeded. And who made that query? Was it the developer machine? Was it the administrator working on a jump box? Or was it my web server? And it's never really done that before. So that's your CloudTrail data. Your CloudTrail data is really a ton of information about the environment, interactions with the environment. But you're also going to want to kind of look at maybe things that are happening with applications themselves. If you're running a web server inside of your environment, there may be a network attack against that web server, maybe a brute force attack, such as an SSH brute force attack or an FTP brute force attack. I know we're running FTP servers in our environments, right? I mean, as much as we probably don't want to, we are. And a remote desktop, there's other kinds of protocols that might be open to the internet that an attacker might try to attack and gain access. From the attacker perspective, this doesn't really look different than an on-prem. I see there's a port 22 open, I'm going to try and attack it. But we have different ways of collecting network traffic. In our on-prem environment, we've probably got a big piece of equipment sitting on that gateway that's gathering up all of our packets, and I'm analyzing them in real time with some service. But I may not have that in AWS. AWS does have a service called VPC Flow Logs, and VPC Flow Logs gives you the ability to look at packets, at least the metadata of the packets, not the full packet, but the metadata of the packet going across the network interfaces. And you have some ability to say whether I want all my network interfaces, or maybe I just care about the subnet that's open on the internet, but whatever it is, you can grab these flow logs and it will store it into an S3 bucket, and you can go and analyze it. Just a quick look at what the VPC flow logs look like. And I apologize, I realized that I have some arrows at the end that are a little messed up. So I'm going to fix those. Yeah. So, and then action would be right here. There. Okay. Really terrible arrows. I realize that, but it's with a mouse. Anyways, if you look at this data, it's not full packet capture. It's like NetFlow data. Like it's, hey, there was a communication between two systems. In this little demo, the account here is 12345. It's called basic fake, but there's an interface ID. This is a network, an elastic network interface that belongs to probably an EC2. It could belong to a number of services. Could be an API gateway. It could be, I don't know, just there's a lot of services in Amazon that have ENIs. Right here, I can't really tell what it is, but we'll make an assumption that this is like an EC2. I've got my source and destination IP address, which is also really nice. I got my source port and my destination port. Now, here we got a destination port of 3389. So that might tell me, hey, which service is this trying to hit? But in actuality, I don't really know the service. I just know the port. Since VPC flow logs really don't look at the packet content itself, I can just say, hey, this is probably one, RDP or whatever service based off of the destination ports, but I don't really know unless I've done a good job of ensuring that only certain services are running with standardized ports, which is we're hoping we're doing inside your environments. The number of packets start and stop. This is what you get for VPC flow logs. Now, you do have the ability to say, hey, I want to get full capture from a particular ENI. So you can do port mirroring inside AWS, or you can create your environment so that you have a collection of all this data, and this network traffic going through an EC2, and you do your own collection. But just out as most of the time, what we're going to look at is we're going to look at these flow data. So this flow data can tell me that, hey, someone has attempted to hit port 3389. I can see I have a rejection at the end. So that actually tells me, hey, someone attempted to do something. It failed. That's great. That's fine. I definitely want to say, hey, was there an attempted SSH? Was there a attempted RDP brute force? If there were 100 packets in a minute that were a failed SSH, that might tell me that there is a problem and someone's doing a brute force attack. When you take this data, you can use things like Athena or some other services to analyze this data across multiple services, across multiple data points to try and look at the whole. An individual packet usually doesn't tell me a lot of information. I got to collect them together with other things. In threat hunting, one thing I like to recommend is that, collecting all your VPC flow logs is fine, but it really becomes interesting if you already are thinking, hey, there's something going on with this particular EC2. Let's say from our previous example, we start seeing AWS S3 LS. So someone has attempted to list the buckets and it was failing on an EC2. That might be interesting. So in that EC2, I may want to say, hey, what's all the network traffic happening right now? Do I see somebody connecting to it from somewhere else? I could turn on VPC flow logs for a particular instance and start gathering that data and say, okay, I'm going to start my investigation. I'm going to extract this data in a different, specifically as part of an ongoing investigation. Because Amazon and in cloud services in general allow self-service and they allow elasticity, they allow automation, right? And so I can automatically start creating these flows and analyze this data based off of an investigation. So VPC flow logs, there's two places, main places you can send the data. You can send the data to an S3 bucket, which what they'll do is it'll take a whole bunch of a whole bunch of VPC flow logs, collect them together, gzip them, drop them into an S3 bucket. You can build code to go and tear them apart and analyze them, or you can use Athena, which is an Amazon service that does analysis across data sets inside S3. And Athena can extract the data and let you run SQL queries across them. So really nice and handy. You can do it that way. You could also send your stuff to CloudWatch. And so CloudWatch, which I'll talk a little more in a second, but CloudWatch will look at every flow log individually instead of as a group. And each flow log individually, you can start writing filters based off of it. So I can run a filter that says, hey, I see 5 SSH failures in a minute, maybe do an investigation. Not in my organization because I mistype, my password a lot. So, they would catch me just forgetting what my password is on Monday morning. But you have to kind of figure out what your threshold is there. All right. So another one to look at is OWASP, right? We mentioned before that there are a lot of attacks that you'll see through the web services because once we start moving our workloads to a cloud environment, we're probably starting to move things into web-like communications. And if there's an attack against a web server, that's really outside of AWS's sphere of visualization, right? You can maybe look at network traffic, but not network traffic, but VPC flow logs, but it's just going to be a bunch of port 443 and that's it, right? So you have WAFs, you have other services. Amazon's new firewall service too will be able to look at the packets, but you can also go and maybe interested in pulling the data that's on the EC2 itself. In a web server running on an EC2, you could be collecting a whole bunch of logs. So maybe I want to go and grab those logs and do something with it. One way you can do that is with CloudWatch and something called the CloudWatch agent. CloudWatch is a service. I hinted at it before, but CloudWatch allows you to pull logs from lots of different places and in a kind of a centralized environment and start building queries off of them. Or you can bring in the logs and ship them to somewhere else that's actually going to do work on them. Like you could throw them to Elasticsearch, you could send them to your Lambda server, or you could send them to a third-party service. But CloudWatch will look at every one of the logs, and you can start building filters on your logs, whether they're Nginx connection logs or they're, VPC flow logs. And the example I was looking at the previous page, I'll go back to look, broken access control. Someone is trying to interact with my web server and maybe gain access to the root directory to pull, the password shadow file, right? So they're doing something to manipulate the web application itself. It has a vulnerability. And I might be able to see that in the connection log. So every time that user hits a URL, that URL can be tracked by Nginx can store that into a log. I could ship those logs into my CloudWatch. And then I can take that and start piping it into my AWS environment to do things like Lambda analysis, analyze it with Elasticsearch or whatever that service is. There's going to be a lot of logs collected in CloudWatch. Every one of your Lambda services, your ECS containers, all get thrown into CloudWatch. You can separate these things in cloud and log groups, but there's just going to be a ton of stuff. And that log management is something you have to spend a little bit of time making sure that you kind of think about what's the name of the log group so I can analyze across all my Nginx servers from the marketing team. I might want to put them all together with a common name, but it can get out of hand. So just something to keep mindful of. So CloudWatch is a fantastic service to go and grab that data, analyze that data. And one of the things that Amazon is doing is giving some new service to help with analysis. And one of them is the CloudWatch Log Insights service. So this service takes those logs, and if it can understand the format of the logs, it will quickly allow you to query the information in a query language. It's not at all like SQL, but it has some flavors to it, but it's very specific to these logs. In this particular case on this screen, this is actually a VPC flow log. CloudWatch Log Insight says, oh, I know what VPC flow logs look like. I will give you the specific properties, and you can query on those properties. VPC flow logs, CloudTrail, Lambda logs, and Route 53 logs, all Log Insight understands how to use. If it's another log format, and JSON, it also can auto-detect JSON and kind of understand how to let you query those. It flattens it out, so it can be a little cumbersome if you've got really crazy JSON logs. Most of the logs coming back from JSON aren't too difficult. But you also have a parse command where you can specifically say, hey, I want to analyze these groups of logs. This is how I would parse the logs and how I would query it. So you can create these. You can these logs. You can get some kind of nice dashboarding. If you're going to have a full-time team that's doing a lot of analysis, you're probably starting to ship this stuff to maybe Elasticsearch or maybe to a third-party SIEM or something like that. But this is a great, quick, dirty, I've got some logs, let me analyze it, which is a lot of what we want our threat hunters to be able to do. So there's some other tools out there, which, never have time. We could talk all day about these. What you do there, we have a class, Security 541, which we take this and we expand it over a full day. But besides our CloudTrail and our VPC flow logs that are being generated by Amazon and our CloudWatch services, which we can go and send our own customized log, you're probably going to be looking at things like AWS config, which AWS config allows you to say, hey, look for this, this is my configured requirement, such as all my S3 buckets have to be encrypted. And it will look and say, okay, all your S3 buckets are encrypted. And if you create an S3 bucket that's not encrypted, it will tell you. AWS config will also do an inventory, and you can set up a snapshot. So every 15 minutes, you get like a giant JSON file of all of your resources and how they're configured. Now it's big, but if you're doing threat hunting and you're like, okay, I got to figure out what my environment looks like, and you put the tools in ahead of time, you could go and query that inventory and get an idea of these are the services, or these are the EC2s that are running at this particular time, and what I need to go look at. I'm thinking in my mind when I say that, but I should articulate it. I'm thinking about that world where you probably have EC2s that are being created and deleted all the time, right? In that elasticity. And so if you're doing, if something happens on a Tuesday, but your threat hunt team isn't able to look at it till Friday, well, that EC2 might be gone, right? you could probably start storing these AWS config data and start looking over long-term to figure out what was all the EC2s on Tuesday and how were they configured. AWS Inspector scans an EC2 system, has some pretty basic ability to analyze things like, are there CVEs? How does the instance match to the CIS benchmark? Some other ones like that. But the inspector can detect problems pretty quickly. And I like things like Inspector because it will actively go out, pull, scan the environment. It can pull, says, hey, there's something weird. It could start off sending something to Lambda to say, you need to go and create an alert inside the ticket system and start pulling VPC flow logs, right? You can start automating the pull of these logs, which is something I really like doing in AWS. GuardDuty and Security Hub and Detective are 3 services that are security-focused managed services by AWS. It pulls together the data that we're looking at here, plus others. And GuardDuty will use, has its own set of rules to do detection of a threat. So it will detect SSH brute force attacks, just like what we talked about in a few slides ago. It will create an alert. And you can go and look at GuardDuty and say, all right, these are the things that Amazon is looking for. And you can detect some things in GuardDuty. Security Hub manages events coming from GuardDuty, but also from Inspector and Config. And it gives you a place to go and say, all right, here's some events. I'm going to go and look at the first one, look at the second one, look at the third one, and kind of work through the process. AWS Detective is a newer service. I think it came out last year. I believe it was last year. And Detective helps with investigation of environment. It allows you to pivot through a lot of different resources that are maybe kind of disconjointed. So if you have an event, you can start off there and start asking questions of the environment to get full information. That brings me to the end of the talk. It's just a quick look at some of the, a couple different threats. And I try to pick ones that are really different from each other. And what are the AWS tools and services that you might want to start looking at to go and extract that log information for your threat hunters. I'll leave you with this. I'm a big proponent of the fact that threat hunting is about looking at logs, but it's also about understanding your architecture and identifying quickly places to improve that architecture. And so I hope in your threat hunting program, you start also creating this, this process to allow the threat hunters to be able to give information back to the architecture team and create the cycle to make that threat hunting better and better. And with that, I think I got 2 minutes, so I'll open up to questions.
Awesome. Thanks a lot, Sean. Great information. We do have a couple questions, so the timing is perfect here.
All right, good.
Can you talk a little bit about kind of the cost associated with logging and also retention for the logs?
Yeah, so like by default, you can query like CloudTrail logs, and they live for 90 days. But you can specify that you want to keep them longer, and so you're paying for most of your payment is usually storage. So if you're going to keep these logs around for 10 years, you're going to be racking up some cost. So, but in threat hunting, you're really probably looking at some. Well, let me rephrase this. When you're starting to do threat hunting, you need to kind of have an idea that says, we're going to look at logs for the past 30 days, and that's it. You got to have some kind of cutoff saying this is the realm of what we're going to look at. And that data needs to be easily available and searchable and can be analyzed. You might say, hey, look, there might be something happened a year ago. We probably want those logs, but we probably don't want to make, we want it to be cheaper. So we'll send them to like Glacier or some other kind of service. But I always recommend as an organization, figure out your log retention and then program your environment around that log retention. The AWS CloudTrail, S3, CloudWatch, you can all specify retentions in those, and those retentions will be automated. So you can say keep for a week, and Amazon will handle deleting those files.
Great. Now you talked about CloudWatch. Just from a comparison perspective, we've got a question. Is that comparable to Azure Log Analytics?
Yeah. And so I would say yes and no. They're from a terms of what logs can be collected and how you would make use of them, there's very much similarities in Azure. Azure does have different services, managed services to help you make sense of those logs. And so Azure has things like Sentinel and other things that are different in what it can detect and also give you a different environment to do that detection. Azure has things like Security Hub, GuardDuty, and Detective that you might use together, but there are 3 different services. So you can get the same kind of data, but it's going to be the way you interact with that data might be a little bit different.
Mhm.
But as we're talking, kind of mentioned in other talks, you want to try and automate as much as possible. Both of those services allow you to or both of those environments allow you to automate pulling the data, analyzing the data, doing something with the data if you know what to do, how you want to analyze it beforehand.
All right. Well, awesome. Thanks a lot, Sean. There's a couple, maybe another 1 or 2 questions here. We're going to transfer over to Slack. But everybody, let's give Sean a virtual round of applause. Sean, thank you so much for sharing this information.
All right. Thank you.
All right, everyone. Now we're going to segue to our very last session of the day. And we're going to be closing out the Cloud Security Solutions Forum here with our panel discussion. Now, we've got a number of panelists here that you see on the slide. We've got Sunil Yu, who's the CISO in residence at YL Ventures. Brandon Evans, who if you were here earlier in the forum, you saw him present on serverless earlier today. We've got Josh Thurston, who's a prior category leader at AWS, focusing on cloud security. And of course, we have Nathan Case here, senior security strategist at AWS. I'm going to go ahead and invite everybody to turn on your cameras here to let the audience see you. And we're going to go ahead and kick off the panel here. Let's just do a quick sound check. If everybody can unmute yourselves and just go around and say a virtual hello to everybody.
Hello.
Hello.
Hey, how's it going?
Hi, this is Josh.
All right, excellent. I see Sunil, I see Josh, I see Brandon, I see Nathan. All right, excellent. Nice to have you guys all here. So let's go ahead and dive in with the first question. The way that this is going to work is, I'll be presenting various questions to the panelists here. And, while the question might be directed at one person to start, certainly we are expecting other people to jump on in on that particular question as well. So I want to go ahead and start with a question for Nathan here is, hey, when you're first moving to the cloud or you're maturing your cloud security capabilities, what do you need to first think about? How should organizations think about about cloud governance in this context?
So from my point of view, the best conversations I have, the best interactions I have with a customer, typically with a CISO, as we sit down and they look at me and say, it's time to go to the cloud. What do we want to do? It's that discussion around what is it that you actually want to get out of it. Let's talk about the initial business cases. Let's talk about the initial governance that goes into it. And governance can mean a lot of things to a lot of people. In my opinion, in this particular case, it really means specific things that we have to do as security people, as compliance people, to make sure that what we're doing in the cloud meets our corporate expectation of secure and okay. So it's a lot of talking. It's surprisingly more talking than most people really want to do, I think, probably. There's a lot of let's go do stuff. And I think let's go do stuff is great. But I think we definitely need to pair that with the let's sit down and talk about what the rules are actually going to be, write those down. And believe it or not, yes, I really mean on paper. And then at the end of that, come to a rational way to go ahead and turn those paper rules into something technical. In many cases, Python or whatever else that you're going to go ahead and utilize to do the compliance checks at the very end of this whole thing. Because what we really end up with is this concept of governance at the front that has policies. These policies end up turning into compliance checks. And then we need to make sure that we evaluate those compliance checks back to our governance policies at the very beginning. Mm-hmm. So it really is kind of a chain of things that need to happen in order.
Yeah, while other people are thinking about chiming in here, you mentioned business requirements, right? You're really talking about what are the business goals, objectives, what are the strategic objectives of the organization? What are some examples of that? Do you have an example of that and how that is tied from your high-level policy down to a specific service or implementation?
Well, HIP is a great one. I mean, we can go through that. We've got the whole cyber defense matrix. We've got wonderful people here that would like to talk to you about that, I'm sure. But it really does come down to what are the governance, what are the regulatory pieces, what are the pieces that we're going to decide as a business. That might be encryption at rest, that might be a certain level of encryption at transit, that might be a certain level of, maybe we've decided that we want to go with zero trust types of architectures. Great, totally cool, but we need to write that down so that we can check that in the compliance engine, and then we can also evaluate that from a developer's point of view.
Mm-hmm. Perfect. Now you kind of teased kind of one of our other topics here. You mentioned the cyber defense matrix here, and For those of you that don't know, Sunil Yu is the one that has started the Cyber Defense Matrix, available online. Sunil, you want to give our audience here just a high-level overview to start of the Cyber Defense Matrix?
Sure. Yeah, so it's a really simple construct. At its core is made up of these two dimensions. On the one dimension, it's the 5 functions of the NIST cybersecurity framework: identify, protect, detect, respond, recover. And the other dimension are 5 types of assets that we care about: devices, applications, networks, data, and users. And these 2 dimensions create this 5x5 grid. It looks pretty much like a bingo card. Unfortunately, there are no free spaces, but that's it. It's this bingo card that helps us frame the type of activities that we need to perform when we're trying to secure our environment. And oftentimes when it comes to security, the thing that burns us is when we miss something. The thing that burns us is when we forgot to take care of something. And the Cyber Defense Matrix just provides a simple construct to help us. It's a mental model that we can use to ensure that we've covered our bases. And whether it's working with your own environment inside your own enterprise on premise, or you're doing it on somebody else's computer, namely the cloud, it still provides us. It provides a great reference point to be able to say, here are all the things I need to worry about, and here's all the things I need to make sure I cover to have a complete security program.
Mm-hmm. Great. Hey, Brandon, I want to turn to you here. Sunil just mentioned users, data, networks, applications, devices. What is different in the cloud when it comes to protecting different types of assets?
It's a great question. I think the first way I'll answer that question is a disclosure with regards to my experience. Now, I think that for me, outside of creating a lot of things on a freelance basis, a lot of things that were for small companies, I've had the, quite frankly, luxury of only really developing in the cloud. It's become the norm to me. And it's really where I think most folks who are coming out of school and learning how to develop are really going. So I think that we really need to invest a lot of energy into that, because that's becoming the new normal. Working on premises is not something that's necessarily attracting people out of school. But in general, I think that a lot of the responsibility is taken off of you in terms of creating the services and the tools necessary to secure things like user data and networking. Amazon, Azure, GCP, they all provide a myriad of tools that you can use that were inconceivable prior to the cloud in terms of ways of locking down things. It's really up to you to understand how those services work and how to properly apply the controls that those services provide in order to secure your data, your network, et cetera.
Mm-hmm. Perfect. Yeah, Josh, I want to turn to you here. What's your perspective? Is how should we be thinking about our cloud defenses, and how does it change the way that we operate?
Yeah, I think that once I had started working with Sunil in previous projects on Cyber Defense Matrix, it changed my view in 2 ways. One is looking at the capabilities that the end user has to assess for, we'll call it their cyber estate. And moving into cloud architectures, you start thinking of, one of the asset types is device. Well, as Sunil and I start talking about that, what is a device? You move towards it. Fundamentally comes down, it's an operating system with an IP address. So therefore, it could be a physical laptop, server, a virtual host, or a cloud instance like an Amazon machine instance or image. And then you start thinking about, well, then what does a container mean to me in the form of an asset? What does a Lambda function? And you start really thinking about your assets and how you categorize them, but then you immediately make that jump to, how do I understand capabilities that I need for that asset as the industry continues to evolve? And so, the customer has to stay up to speed with that. The Cyber Defense Matrix helps. The other thing that I started to pivot and think of differently is, well, if I'm a vendor and I'm creating technology or services, how does this change my perspective? And especially with, if I'm in the product management and engineering space, and I wanted to think about how do I push the envelope further of new capabilities in my product. Well, what better way than go look at it in Cyber Defense Matrix, map out your solution and figure out, here's the area that I don't have capability, but I could easily jump to that and start building out. So I start looking at it through capabilities, and this matrix or grid view is really changed the way that I start addressing security capabilities.
Great. Hey, before we dive more into detail on some of this, I just want to open it up to the audience as well. I did see a couple people. A couple questions come in. Feel free, if you have any questions for the panelists, share them here in our chat window at any time. And to dive a little bit more specifically, we actually do have a question here in terms of what about penetration testing? Organizations have been doing pen testing for a long time. And, first, I'm going to have, both Brandon and Nathan here. Brandon, Nathan was just talking about, well, hey, instances, containers, serverless. You spoke about serverless earlier. From a pen testing perspective, kind of what's different about it in the cloud?
A lot of it's different. A lot of it's, sorry, go on.
Yeah, no, please, after you.
Okay. There's a lot of differences, a lot of similarities. Fundamentally, our applications are still running on hardware. Serverless does not mean that there are no servers. It means that we pretend that they don't exist or that they are not ours as an abstraction away from us having to manage that. But we still have to understand the different environments with serverless containers, VMs. We need to make sure that the standards that AWS, Azure, GCP are meeting the standards of our organization. But more oftentimes, it's not about penetration testing AWS. Because we probably would find out if there was a critical vulnerability in S3 by now. So many people have had their hands in that cookie jar. But it's usually about how we use those tools, the configurations. I mentioned a couple examples of that in the serverless section. We talked about execution role and the IAM permissions associated with your function. Why should your function be an administrator? The answer is it shouldn't. You should give it exactly the permissions that it needs to access the appropriate resources. So if there is an application security flaw, which once again still matters in any environment, regardless of what maybe some people would like to think, you need to see if that application security issue can be exploited to get those credentials. Now I have access to far more things than I would have otherwise if I was configuring this properly. The same argument goes for network security. The same argument goes for encryption. It's really about your secure configuration. And of course, doing application security in the cloud is no different than on-premise.
Great. Anyone else want to chime in here on this topic of pen testing before we switch gears?
So yeah, I'll jump in real quick. I completely agree with Brandon here. It really is one of those things that you have to keep doing in the cloud. And I get that people think, well, hey, it's a new thing. Maybe we don't have to, or maybe we can get around it. And I know that's totally human nature and we're all there, but the reality is you do need to keep pen testing. I think my favorite hack from last year was a company that had USBs sprinkled in the parking lot. It had nothing to do with the cloud. It had nothing to do with anything else. It was totally a process procedure sort of a thing. And part of pen testing is making sure that all of the things that you have are locked down and you understand the process procedures that are going on in your company. And do you have your USB ports blocked correctly? It's not really the cloud. It will lead to the cloud. And part of that is, kind of understanding the whole chain of events, the whole thing that's going on there. So pen testing is important. Pen testing is good. I would posit that things like Prowler and Scout are, things that should be very common to your developers. I had a developer come to me this week and say, is it okay if I run Scout Suite on my stuff? And I kind of looked at them and went, please run it as much as you'd like. Please help us.
Yeah, and of course, Nathan just mentioned a couple free open source tools, Prowler, Scout Suite, used for looking for security issues and misconfigurations in your environment. So very popular tools, absolutely. Anyone else on the topic of pen testing here? Sunil?
Yeah, I wanted to offer, what I think is really useful around pen testing is the challenging of our assumptions, and the red team activities as well. They really are meant to help challenge our assumptions. When it comes to the use of public cloud, if we go in with a perspective that all our assumptions, both explicit and implicit, are still valid, then I think we'll find out pretty quickly that that's not going to be true, right? We'll find that our implicit or explicit assumptions about, let's say, a network perimeter being a foundation for our security controls, that assumption falls apart given the nature of how the cloud is, right? We talk about identity being the new perimeter, but I would argue actually identity's always been our perimeter. We just call it the network identity, namely like an IP address. So now we realize now the network identity doesn't have as much trustworthiness as we used to have, or we used to think that we used to have in traditional environments. So now we have to figure out what can give us more trustworthiness, or how do we build more trustworthiness into some of these other identities that we can rely upon that help provide some of the controls that we need. And so the whole perspective of pen testing, I think, applies regardless of wherever you are, because ultimately it's about challenging one's assumptions that you come in with. And if you can systematically do that in whatever environment, whether it's cloud, on-premise, or the next new thing, that's going to be an activity that we would want to continue.
Mm-hmm. Yeah, over the years, I've had a number of pen testing teams, assessment teams, and doing various security reviews. And typically, traditionally, when somebody comes to us and says, "Hey, we would like you to do a pen test," we might scope that out and might take a couple weeks, let's say. So we've got a question that came in here is that, hey, one of the challenges that the person in the audience faces is that with Agile, with modern DevOps practices, is they move faster. And how can the pace or lack thereof of pen testing kind of keep up with this pace of modern development? I'll open it up to the group here.
So I definitely think it's a great question. I think part of it is understanding that doing a full penetration test for every release that an agile team has is simply not possible anymore. You cannot have a full, several week-long penetration test. That doesn't mean you can't build in security controls throughout the pipeline. We talked about this extensively in Sec 540, cloud security and DevOps automation. How do we shift left a lot of these checks? We can do static analysis in the coding pipeline, perhaps not the entire scan, but perhaps an incremental scan where we look at the differences in this deployment other than in comparison to the previous one. And if you do all these kind of things, dynamic analysis, dependency checking, if you do all these things, it really lowers the bar for what the penetration testers have to do, because now they're going to focus a lot of their energy on these more complex attacks. And one final thing I'll mention on this subject is I mentioned dynamic analysis. There's also the capability of doing integration tests where you build out acceptance test cases and you test that against your API or your application. So why not automate the findings such that when there's a finding in one of your penetration tests, you build out a script that will validate whether or not that finding has been fixed or not. Now you don't have to have your penetration testers retest previous vulnerabilities. They can focus 100% of their energy on looking at new vulnerabilities. So that will make the effort much faster, but we also have to understand that full penetration tests cannot happen for every release, especially when you have 100, 1,000 deploys a day.
Let me offer even more radical view, if you don't mind. So I was wondering this other day. I was reading Ed Amoroso's post on LinkedIn. He was talking about what makes a good defense, and he said, well, a good defense, we think in some respects maybe a good offense makes a good defense, and he said, no, a good defense is made by a good defense. You have to really focus on the solid principles around how we defend things. I would actually disagree with that view and say a good defense is made by changing the rules of the game. A good defense is by having the attacker have to catch up with us because we keep changing what the rules of the game are. So consider this for a moment. What is happening with every release of a piece of software? We are changing the rules of the game for the attacker. They now have to figure out this new thing that we just rolled out, right? And suppose we do that constantly, repeatedly, and as much as possible, that application changes, not because we're trying to defeat the attacker, but because we're trying to drive business value, right? if you were an attacker, you had to constantly keep up with this latest change, latest update, latest whatever, it'd be maddening because you thought you got something and all of a sudden now the application has changed. Now, where the application doesn't change are your potential weak points, because now the attacker has time to go and probe it and figure out what's going on. But so do you, then, right? At that point, you have a chance to fully penetration test it and see, are there weaknesses in some of these core parts that maybe may not change very often. And so that's another way to look at penetration testing. I wouldn't penetration test those things that, again, are constantly changing, because honestly, it's going to be really hard for the attacker to even catch up. And you don't want to slow the business down in those situations. I think it's important that they, for business sake, but also in many ways, again, what makes a good defense is one that where you're, again, constantly changing the rules of the game, and the attacker has to catch up and play and understand those rules of the game. And when that's happening, I think that's actually perhaps one of the best defenses that we have in our disposal.
Yeah, excellent.
And I should say, and cloud security and the cloud public cloud environments are really well suited for that, because it enables us to change the rules of the game constantly, and that's we should use that to our benefit.
Yeah, excellent.
And to add on to that, to add on to that, one of the ways you can change the game is simply retire applications that you're no longer using. That's a big thing that a lot of folks don't do, which is tear down things. And the cloud also helps enable that. That's a way of reducing the attack surface at the same time as changing the game.
Yeah, I was just about to unmute and say, you know, the change in making everything more ephemeral is really the dynamic nature of the cloud is making it harder for the adversary, because now things are, boom, come and go. And it's that agile development that you mentioned earlier, Brandon. It's just changing all of that. And the security guys are able to use newer tools like cloud security posture management, cloud workload protection platforms that help them keep pace. But the adversary doesn't have that luxury to keep pace. So it's really starting to tilt the scales, in my opinion.
I think to add to that, like when you look at the things that you can do in any cloud, I mean, obviously I've got my own AWS side of this whole thing, but API gateway and other API management systems, it's really interesting when you start shifting things that are, you used to run it on a specific open source piece of software and there were known issues with that. But if you can switch it to the left just a little bit, it's interesting how your architecture suddenly becomes more secure. So like I was talking to a developer this week even, and he was building out a whole EC2 cluster with open source web server and this really whole complex thing that looked just like we would have built it in a data center. And he had all of these things that he hadn't planned for. He hadn't thought about DDoS. He hadn't thought about WAF. He hadn't, just the whole list went on and on and on. And I literally just went ahead and picked it up and put it in Fargate and then put API gateway in front of it and went, and we're done. But if you haven't thought about it from like architectural points of view all the way through and thought about the things that you have to do when we come back to governance, and not to like bring this whole thing back around, but if you haven't thought about it from a governance point of view, the things you have to have, you get to this point where somebody starts building something and they like what they've built, and you may not have a way to argue to them or convince them that, hey, there's a more secure way to do this. This is the way we suggest you do it.
Yeah.
So
a few moments ago, Sunil mentioned, hey, maybe some people might say identity is the new perimeter, but Sunil points out that, hey, maybe the network identity has been the identity perimeter for the whole time, albeit a simplistic one. So let's go back to first principles here a little bit, and maybe start with Sunil and go around. Is how does the cloud enable defensible infrastructure? What are those principles in terms of what it means to actually be defensible?
Sure. Yeah. So Josh actually mentioned this briefly in one of the principles I consider. When I've been thinking about defensible infrastructure, again, I talk about changing the rules of the game as a part of that. But there's also another perspective around how do you engineer towards defensible infrastructure? And we traditionally would think of defensible infrastructure or security in the context of the CIA triad. We aim for confidentiality, integrity, and availability. But honestly, I mean, I'm a security guy. I understand those principles, but I'm not sure exactly if I can set a very clear goal of saying, okay, now this is fully confidential, okay, whatever this thing is, or this thing has full integrity. One what are the benchmarks or the measurements I can put towards that? And it's still very squishy, right? So I came up with a different triad. We have the CIA triad, and then I have what I call the DIE triad. DIE stands for distributed, immutable, and ephemeral. Distributed, immutable, and ephemeral. And those are actually very measurable. I can measure ephemerality. How long-lived is something? I can measure immutability. Has it ever changed? Well, anything greater than 0 means that it's changed. Therefore, you violate immutability. Let's try to avoid that. And then distributed, again, that can be something that's moves towards infinity, but nonetheless, you can say how distributed is this service or this component that I have. And what's really cool is that when I think about defensible infrastructure, if I build towards DIE, that actually sets the foundation for what is more defensible. Fortunately, I think the public cloud provides that as a core set of propositions around how you build defensible things inside the cloud. You build them to be distributed. You build them to be immutable. You build them to be ephemeral. And if you've heard of the pets versus cattle analogy in the cloud native world, DIE is meant for cattle. You build cattle to be like to be distributed, immutable, and ephemeral. Conversely, if you have a pet, then you have to CIA it. Okay, you have to practice the principles of CIA because you can't lose that pet. And if you're going to put that pet in the cloud without the proper set of controls, that pet's going to get run over, and you're going to have a bad day. And people are emotionally attached to that pet, and so the just being sure that you understand the fact that you're putting this pet in harm's way. If you don't put the necessary protections around that pet in the cloud, then again, you're not gonna have a great outcome.
I love your acronym, and I think it's incredible. But I do want to add something to it that definitely doesn't make sense in the acronym sense, which is short-lived. DIEs, that doesn't sound nearly as good. But like Nathan said before, having sorry, I got myself mixed up. That was one of your principles. I meant less infrastructure, less ephemerality set. I'm sorry, I got all mixed up. L, less infrastructure. I want less infrastructure. Instead of having all these EC2 clusters, like Nathan said, have less. Take down infrastructure that you're not using. Take off applications that you're not using. Have serverless functions where it's plausible to have less long-term systems, and that would immediately lend itself to the DIE triad as well. So I don't know how you can rename it to fit that idea, but you need less infrastructure. It's just not as catchy, unfortunately.
Maybe we change it to DICE, distributed, immutable, consolidated, and ephemeral. We'll call it the DICE quadrant.
Yeah, I mean, I guess you can dice up. I guess you can dice up cattle, but it still sounds weirder than just die cattle.
Hey, the best hamburgers are made with sacred cows.
That's right.
Yeah, and we're really talking about reducing the attack surface here, and kind of going back to the concept of attacks. One audience member here posed a question. Interesting question here is back to that idea of constantly changing the apps. Is things are ephemeral. Infrastructure as code enables this, and modern development practices and containers enable this. But let's say that the adversary is an AI that someday maybe can deal with the speed and volume of change. Hey, what about that potential future scenario? What do you guys think?
I think the last of our problems will be cybersecurity at that point. But that said, it is some degree of war of escalation, right? And ultimately, it's again mind versus some person coming up with creative ways to do things, and somebody else trying to find a way to counter that creativity, right? And it's a back and forth discussion that goes. Actually, the one principle I would apply, and I'm trying to think of the original quote, but it was something like this: with all your cleverness, if you program something with all your cleverness, it takes twice that cleverness to find bugs and flaws in it. Okay, so that's what I would hope for. That over time we will essentially continue to increase our own cleverness by being on the offense ourselves in terms of creating these new things. And as long as we continue to push the boundaries of that, then it'll be hard for anybody to catch up, let alone an AI.
Yeah, it's interesting you mentioned that quote. It actually reminds me of another quote that almost leads us to a very different conclusion, which is that clever code makes for clever bugs. So oftentimes, a lot of the security vulnerabilities come about from a company doing something that seems clever at the time, but in reality, it is a hack. But I completely agree with you that I don't see why it would be that AI would be able to attack faster than we can defend. And I am frankly extremely skeptical that AI can do either of those two things in a meaningful way. We are not replacing developers with AI. We can barely replace some of the developers who retire or leave companies with other developers of the same skill set. It's just a very hard problem to solve. So if someone can make an AI that can attack, I'd be very impressed. I'm sure it'll eventually happen, but I think that a lot of it will be overblown as well. AI is scary in principle. In reality, it rarely manifests itself into anything of that magnitude.
I would weigh in that I think Sunil is probably right here. If we go down this path, and Brandon too, I suppose. I mean, cyber defense means something totally different at this point. Let's be honest. We're playing Terminator for real. But when we get down this path, and it's a fun mind game, you know. Or what happens if we have, you know, AI that can attack? Well, then most likely we'll have AI that can defend, and, you know, again we go back to stalemate. So I think that we go back to the principles again. Like, okay, cool. So now we have a faster attacker and we have a faster defender. Great. But I expect the meat in the seat, us, to still be the weak point in all of those expectations, right? I mean, like, we are the weak point that an attacker will attack first. There's a reason that ransomware has seen a rise. There's a reason that all of these things, I mean, I told the joke about the USBs in the parking lot. There's a reason that people still use USBs in the parking lot. I still use USBs in the parking lot as a red teamer. I will write Mikey's homework on the USB, and sure enough, someone will plug it in because they really need to see Mikey's homework. It's truly just the human nature that drives us that is really the weak point in all of this. So I'm really happy that you've got an AI attacker, and I'm really happy that you've got an AI defender, but it's so much easier to go after Brandon and you know, send him an email.
Hey, great conversation, guys. While we wait for some additional questions to come in, I did want to switch topics here a little bit. You know, throughout the day, we've heard some info from other speakers about the AWS Marketplace and solutions available there. So Josh, I want to, you know, I know that you've got some background in this area, and, you know, you go to AWS Marketplace or any app store type of thing for that matter, you're just a lot of different options, a lot of different solutions. You know, how should organizations be thinking about, well, when do you use a cloud native solution versus the vendor provided solution versus, you know, looking for the right tool in someplace like AWS Marketplace? What's your advice?
Yeah, I think rule number one is you gotta really get back to understanding your capabilities. You know, what are you looking for? You know, what is your use case and the outcome that you're dare I say chasing, right? So it comes down to, you know, simple examples like, you know, can I identify all of the assets? Can I pull active or a passive inventory of all of my, you know, instances, applications, containers, networks, flows, users, etc. And you work through all of these. You will find in so many cases that through the very large, I think it's 180 plus AWS native services, you will get a lot of the capabilities out of them. The key is that when you look towards meeting those capabilities with AWS, when you start to look at the vendors that are in there, you start getting the 1 + 1 actually equals 3, because they start giving you more efficiencies and more control or more structured visibility. Things like, hey, I can go grab event data out of something like Security Hub, but if I take Security Hub data and put it into an industry's you know, newer SIEM, now I have maybe more advanced correlation aggregation, and I can bring in data, and I have a different type of insight where the security hub was good, but now we go and say, now we're great. We can really see the proverbial needle in the haystack and meet something more than just compliance. You can also get into other, really good examples, like taking all of these native events out of, the applications, the containers, the instances, and you can consume those. The data is there. Use those native services to extract the data. But when you go and put them into an EDR solution or like a UEBA solution, you're taking it up, that extra notch. So I always encourage people, look at the native services as the ability to get quicker, dare I say cheaper visibility and access, but use these third-party solutions to take it up to that next layer or that next capability set to really drive efficiency and get closer to that perfect scenario of protect and detect, and then move into the recover and respond and recover. Excuse me.
Other comments before we move on to the next topic here?
I will say that I think there's a huge trend in developers, operations, et cetera, to try to stay in one ecosystem if they can manage it. And I think AWS has done an amazing job from a psychology perspective in getting folks in that area. If there is a cloud native solution that works, why not stay within the same ecosystem? So I think it's great that AWS is investing further into promoting those third-party solutions and saying, hey, there are things that we simply are not going to specialize in. We have 175 plus services. There are other companies working full-time on this one area, and we'd like to promote them in the context of our marketplace. So I think that's phenomenal.
All right, so in terms of switching topics here, let's switch gears and let's talk about China. So I think we may all be familiar with the fact that China has a Cybersecurity Act, that one of the things that is maybe unique compared to some other parts of the world is that they have a data residency requirement, right? At a high level, they say that, hey, important data and systems need to be reside in China proper itself, within the border. So the audience member's question here is, hey, between public clouds that are for the most part available in most of the world, well, how would you compare that with what is available in China? What do we need to think about for us in organizations that have to do business in China versus the rest of the world?
I'll speak to that short bit. I can't say I am a subject matter expert on doing cloud in China. We actually had 2 SANS webcasts recently in which you can get a lot more information on this, one by Ken Hartman and one by Tim Coakley. But I wouldn't say that these are competing things, because AWS can be run in China. There is a China region for AWS, and I don't think people are really recognizing that or fully utilizing it. Is it as feature rich as the other ones? No, but the same thing could be said about GovCloud. And there is clearly Alibaba is the winner in that area, but there are instances in which these public clouds have made their way into China. Google, I believe, has also made some strides in that area.
Yeah, the way that I've always characterized this problem is by framing my test case or my use case for what I would want from a set of security capabilities that I've yet to actually see in the market, but this is what this is my test case. So I would want to run the most sensitive transactions, financial transactions, whatever, okay, on Russian bulletproof hosting. All right, give me the most the worst possible place to run my my workload, and I would want that workload to remain secure, regardless of where it lives. Right, that's the goal. Actually, to go back to my the pets versus cattle analogy, we have a lot of data pets, okay, and we haven't figured out actually a way to elegantly turn them into data cattle instead. And that's what I think that's the challenge or struggle that we as an industry are still trying to figure out how to do. Today, we only know how to operate with data pets. And as a result, when you put a pet in China, it's subject to be compromised. It's subject to be lifted. And the same can be said by people outside the United States who are looking at the US and saying, well, you put your data pet in the US and the NSA is going to snarf it up. So regardless of what country you're in, I think the goal that we would want to try to strive for is to look at ways that we can potentially do the same type of transactions, but not have to always give up our pets in doing so. What we would rather have are techniques that allow us to interact with data cattle, just as much as we have data servers as cattle, applications as cattle, containers as cattle. We haven't really figured out how to make data cattle. And interestingly enough, though, there's a whole set of new technologies that I don't know if a lot of people have really gotten familiar with, but ironically, the acronym for this set of technologies is called the name of these technologies is called Privacy Enhancing Technologies, or PET. But anyway, these privacy enhancing technologies, I think, are a way that we can start figuring out how do we operate with data cattle instead of data pets. So these are things like multi-party computation, homomorphic encryption, trusted execution environments, differential privacy, federated learning. All these are different things that we can use to actually operate with data cattle. But we haven't really figured out how to do that well yet. And I think we've figured that out for a lot of things like infrastructure, but we haven't figured it out. A lot of people are still trying to figure out how to do that with data itself. And once we figure that out, I think this problem that we have with China, I don't think it'll completely go away, but it will certainly reduce our exposure significantly, such that we will feel comfortable in operating in some of these potentially more hostile environments without fearing that we're going to lose our pets every time.
Yeah, very well said. Any other thoughts on that, folks, before we move on? Now, we've had a pretty friendly panel here so far, despite some perhaps efforts to get things riled up, and so it's always good to have something a little bit perhaps maybe incendiary. So we do have one audience question here. Hey, everybody, the panel, what are your thoughts about the FireEye incident this week?
All right, well, let me offer my soundbite on this. I think it's like, so if it were Russia or some nation state actor, I think it was, I would think they would be disappointed. It's like using your most sophisticated tool to go and steal a set of lockpicks that you can buy at Home Depot.
Yeah, stole some open source tools.
Yeah. Now, granted, there were a couple, having done an analysis, there are three. There's a small handful of known exploits that weren't available in the wild, and maybe they picked up those. Okay. I wouldn't be surprised if the ones that they picked up were ones they already had, right? So again, breaking into high security facility only to steal a set of lockpicks that you can buy at a common store. So, but that's it. I certainly, there's some comparisons that I'm seeing towards this being like the biggest hacks in shadow brokers, or like stealing nuclear launch codes. I'm like, no, it's so far, and based on the evidence so far, it's nothing like that.
Mm-hmm.
I would just offer this up as someone who's formerly managed security operations for a security software vendor, high profile, big name in the industry. It pains me to see all of the stuff going across Twitter and LinkedIn where everybody just feels like it's time to double down and bash on them and say, oh, you're a security company and you couldn't keep yourself secure. The job of securing your company is hard pretty much no matter what organization you're protecting, whether you're a financial institution, healthcare, the list goes on and on. When you're a security vendor, in my personal opinion, you actually have more attacks than a lot of the organizations, because the holy grail is, breach government, breach financial institution, breach the security vendors. So you see a very high volume of attacks, and we all know that being able to say we're secure that's a day in and day out thing, right? And there's always a way in. So what we need to do as an industry is be supportive of these security vendors, because it's not a question of if, it's a question of when, and just happens to be this is their time that something happened. We all need to support them. We need to lift them up, and we need to rally around them to figure out how can we all learn from this, and how can we all move forward to get better at security as a larger industry.
And to add on to that real quickly, I think FireEye has done a great job of setting a new bar for the kind of disclosure that we would all want to see.
I think it's important to realize here that it was a security company that got popped here. I mean, as we look at this, I think it should be, what's the best word for this? I think it should be humbling for the rest of us to go, oh wait, they do this for a living and they got it. What are we doing? You know, what tabletops have you guys, has anyone done this month? What technical, attacks have you done against your own systems? What chaos engineering have you looked at? What have you? I know that when I get into a lot of my customers, when I go talk to them, the first thing that comes up is, well, what is this Simian Army stuff? Is this any good? And a lot of it's really funny, but you get into it and you go, well, have you even done a tabletop? Have you done a tabletop to let's sit down and talk about what happens if? And I think I completely agree with Josh. It seems like we like to bash on people like it's high school. And the reality is that, it's going to happen to everybody. And we need to sit down and deal with that fact. And part of that is getting ready for it. And the preparation is every day of the week more important than what happens on that day.
Yep.
Spent the first 4 years of my career here at AWS doing incident response. And it is never a happy morning. It just isn't. But the customers, and there are few that get ready for it and deal with it and have been prepped and ready and trained for it beforehand, always deal with it infinitely better.
Yeah, so much for an incendiary conversation. It seems like we're all on the same page about this. Things happen to even those who are very well prepared. I talked about Capital One and the incident that happened last year that related to an instance metadata service. I briefly mentioned that during my talk. And Capital One has done amazing things for both DevOps and security, amazing things. And they still had an incident in which they were attacked in such a complicated way. And to further add to that, I remember Bruce Schneier, who's one of the most famous security people out there. He did a keynote for LinuxCon 2015. And in that, he mentioned that recently he had gotten phished. Now think about that. Think about someone like at the highest level of security getting phished. It just shows that this is a human element. There are going to be mistakes that are made. So I don't think it's surprising at all that security companies are facing security threats. Everybody does, but they're probably thinking about it more than you are. So really redouble your efforts, just like Nathan mentioned.
All right. Hey, everybody. Great discussion. Great questions so far. We're coming up on the end here. So I want to go around here and give each of you an opportunity to share with the audience kind of what's your one takeaway is, hey, when they go back to work tomorrow, later today, what should they be thinking about from a cloud security perspective? Josh, I'm going to go ahead and start with you.
So from a cloud perspective, I think that there's been this continuous misnomer of I moved to the cloud, therefore I'm not safe, or then there's the other contrast that I moved to the cloud, therefore I am safer. And I think that you need to think of security as a whole and not just say, well, I've moved to the cloud. You need to look at it as I've extended my estate. My estate is no longer in a hosting provider, a colo. It's not in my on-premise data center. I'm actually just extending to this place called the cloud, and immediately go back to revisiting the capabilities. And you might have different capability needs because of how you've extended your estate, but always come back and think of it. This is a big, huge thing that I'm protecting. Go through your iterative process. I need to identify my assets, understand vulnerability, risk. How do I secure them? How do I measure? How do I get back to start. The first is I have to re-identify. Excuse me. So I think that so many people come in and they say, oh, we're moving to the cloud and now we're not having to secure XYZ. No, it's still there. You still have to go through this iterative process. Don't ever stop. It's a day in and day out nebulous thing. And you just have to be vigilant every single day.
All right, great. All right, Nathan, up to you next. Still on mute, Nathan.
Closing statement after a statement like that from Josh is harsh. I would tell you that, going back to the statement we talked about, preparation is worth so much more the morning of an incident. I think that's really important. Looking at your architectures prior to understanding the types of risks you're facing and being honest about it is important. And I would say that the governance thing that we talked about way back at the beginning, and I know that was like 30 minutes ago or whatever, but so many customers get into this concept of we're just going to rush into the cloud, and they make the exact same mistakes they made in the data center. This is so the moment you have to do this the right way, to go back to zero, to plan it out, to execute correctly. Take the opportunity. Go as slow as you need to go to get it done right.
All right, excellent. Brandon, you're up next.
Certainly. So I think when it comes to the cloud, we fundamentally need to understand that security is different. It's not necessarily harder. It's not necessarily easier. It's different. You get so many benefits from being in the cloud. You get to lean on the shared responsibility model. You have all of those capabilities we mentioned earlier with IAM and networking and encryption, all these managed security services, and they're incredibly valuable to your organization. But there's also a lot of new challenges that we're not nearly as familiar with, such as insecure default configurations. Because, hey, we're not building out this platform. We now need to understand how to properly secure it based on their documentation. There's a lot of documentation there. There's also a lack of understanding of cloud platforms under the hood. How do they actually work? And of course, there are compliance concerns potentially depending on what industry you work on, due to the fact that you're fundamentally sharing private data with third parties like Amazon. That is an inevitable part of working with the cloud. So I believe with the right resources, organizations can operate as securely, if not more securely, in the cloud as opposed to on-premises. And because I think that there is a lack of resources out there and it needs to continue doing research in that area, that's why I'm just so proud to be a part of the SANS Cloud Security Curriculum.
Now I'm still on mute here. All right, Sunil, thank you. Thank you, Brandon. Sunil, up to you.
Cattle in the cloud, pets on-prem. Thank you.
Awesome. I love it. I love it. Hey, everybody, thanks for attending the very first cloud security forum here with SANS and AWS Marketplace. Throughout the day, you've heard about a lot of stuff: multi-account strategy, moving operations to the cloud, access management strategy, serverless, threat detection, IR, cloud security monitoring. And we just finished off this the entire forum here with our panel where we talked about, yes, a number of acronyms: DIE, cattle versus pets, and eating hamburgers the right way. With that, we're going to go ahead and sign off. Thank you, everybody, for attending, and we will see you at the next event. Appreciate it.